Welcome everybody to today's session. We'll get started here in just another moment or so. Thanks. Hey, Mac, you out there?
Yes, hello.
Okay, great. So why don't we go ahead and get started here? I'll let you kind of kick things off. We got a slide deck that we probably should have covered yesterday, but let's get going here. I think we're good to go.
Great. I don't have control of the slides, so if you can move them.
Yes, yeah, absolutely. So
for us, that'd be great. Hey, everyone! Just want to welcome those of you that are returning from yesterday back, and anyone new today. Really glad you've joined us today as well. Our security focus today. We're excited to have you join us. We have a number of our solutions engineers supporting Josh here, who's going to deliver this. We have Matt and James, who are both based here in ANZ. Matt in New Zealand, James in Sydney. I'm based in Melbourne, and we'll also have our APAC security lead dropping in later as well too, to answer any deeper questions you might have. Yeah, here we go. There's Stefan. You can see him there. Now, as I mentioned yesterday, the whole point about these certifications is, to enable you to, to gain additional skills which will, improve the impact you can make personally utilizing the Sumo platform. And we've really seen, seen the impact that, these certifications can double and more increase your ability, particularly around utilizing the more complex operators and search optimizations. Sumo is an incredibly powerful platform, so we want you to be to feel confident and comfortable with this, and that's what today's all about. So obviously Josh is going to take you through a whole lot of material, but ask your questions, raise your hand, put things into chat or Q&A, and we've got a team here who are here to help you. If you want to go to the next slide, yeah, we've got a lot of different people across Australia and New Zealand. Today's got a security focus, but we've got a number of DevOps people joining, across, as it says here, 10 cities and 11 different companies. So you're a community, an important community for for us, and the ability to share and ask questions and get input from not only us, but the questioning from others is really important. So do get involved. Do ask questions, large, small. There's no question not worth asking. And then to wrap up, carry on into the agenda today. This is what we're going through. Just a quick introduction now, and then Josh is going to take you through cloud security monitoring and analytics, and then after a break, continue with that, and then after lunch get into the Sumo Cloud SIEM capabilities and go through the fundamentals of that, and then later this afternoon you'll have the chance to do the Cloud SIEM certification. So that's what we're doing today. And lastly, I'll just say that if you pass the certification at the end, just fill in the form that'll be dropped into the chat. This link here, and Sumo will post you a small token of our congratulations, a $15 REITs voucher. So well worth taking the certification, not just to be able to post it on your LinkedIn and brag about it, but I'll also get a free meal for it too. Okay, with that, I'll let you get on with the day. Good luck and enjoy.
Thanks, Mac. Thank you. All right, so as mentioned with the agenda, today is going to be split into 2 different sessions. So yesterday and I'm assuming everybody here was here yesterday. If you weren't, that's perfectly fine. Yeah, I'll reference yesterday a little bit, but other than that, today's a new day. And so we're going to be focusing, as Mac suggested, and hopefully you're aware of, on security. So cloud security monitoring and analytics will be the morning session, and then cloud SIEM fundamentals will be the afternoon. And it's going to be the same kind of breakout that we did yesterday. So 3 hours of a class, 2 hours for content, labs, slides, an hour to take the exam. We'll take a break for lunch and then come back and do it again. So that's the plan. Cool, let's do it. Let's get in here. So let me get this slide deck and let me jump into this one. And for this class, this slide deck, I'm not going to use much at all. Really, I think I have 3 slides in here. Today is really going to be about hands-on labs, which I hope you'll appreciate. But that being said, I do have a couple slides, so let's get at them. So for the agenda for the first half of today, here we are. So introduction. Going to do a quick security demo, and then we're going to do some labs. As you see, a lot of labs, so 8 of them, and then we'll take the certification. Once again, another reminder for the Uber Eats, and we'll remind you about this later as well. If you took the exam yesterday, certainly encourage you to take advantage of this, and you'll get 2 more chances as well today. So potentially 3 free meals on us. So please take advantage of it. It's there for you. All right, now this slide I introduced yesterday, and I'm going to use it again, but kind of zoom through it. And what I was showing here is how Sumo Logic can help you, specifically the continuous intelligence platform, which is what we're focusing on for at least this portion of today. And Sumo can help you in a variety of different ways. And I talked about that operational intelligence, allowing you to see where people are going, what websites they're coming to. Is your MTTI, MTTR, are those adequate? Are they low? How are they compared to what they should be? Security intelligence, and that's where we're really focusing on today, is the ability to start to utilize Sumo to look at things within a security mindset. So are people accessing your website, or excuse me, are users logging in from multiple places at the same time? And should they be? And is that important to you? And other use cases, and I'll show those use cases in a few moments. And then the business intelligence side of things, Sumo's great to let you know, are people going to your website? Are they ordering your product? Where are they ordering it from? Things like that. And then global intelligence, which is really more of that global scale. And then we talked about your data being important with Sumo. Sumo can't really run without your data. And so regardless of where your data is, it needs to be brought into Sumo. And we talked a little bit yesterday about the collection, the idea of collecting your data, bringing it into Sumo. We're not going to go any deeper than that for today, but just important to remember your data is a key portion of all this. And then utilizing our analytics, you start to get a solution. And so as a reminder, our solution is as a multi-tenancy and as scalable, has security and monitoring. We're going to be focusing on that today. Has advanced analytics. We're going to use some of those advanced analytics today, a little bit later. And then with that security mindset, we have those attestations, those certifications that ensure that the Sumo Logic product itself is secure, which is, of course, of utmost importance. And then everybody can benefit from Sumo, not just DevOps people, not just SecOps, which is probably a little more focused for today, but engineering, IT, customer success, yay, Sumo for everybody. Now, that being said, within the security intelligence solution, or solutions, plural, there's a couple different solutions that we offer. The first one, and these are groupings, these aren't really solutions, but ways to use Sumo, is using Sumo for audit and compliance. Utilizing Sumo to look at your collection, see your ingestion, see where your ingestion is coming from, using the apps that we introduced yesterday to make sure that compliance is taking place. Now, that's an important portion of maybe your business, maybe of utilizing Sumo, but it's not going to be the focus for today. Security and analytics is going to be the focus of today, where we're going to go ahead and utilize Sumo and utilize searches and dashboards and things that we used yesterday, but in a security mindset. And so that's where we're going to be focusing today, at least the morning session. Now in the afternoon, we're going to be utilizing Cloud SIEM, which is another security intelligence solution that we offer. And we'll go over that very thoroughly later, but that's for later. So for today, or for now, we're focusing on kind of this middle column here, if you will. And just to expand that out, it's really just expanding that same slide out. Under those security analytics these are some of the things we're going to be covering. So those searches, those queries that you can use to sort through your data. We started to do a query yesterday. We're going to get much more detailed. Using those dashboards as a visual representation or a snapshot representation. And so there's a lot of power in that. Somebody very simply can look at this dashboard as is on the screen and understand, where the geo activity is occurring, the sign-in activity, who the top 10 users are. And we're going to recreate many of these columns or dashboards later today. And then utilizing the advanced analytics. So using some of those search operators, and there's many of them, and we'll use a few of them today. All right, so let me get into my little demo here. It's a pretty quick demo. It's really more of a, well, it's a demo, but really more of a tour. Let's make this, here we go. So what I have here is I've logged into Sumo Logic. And as I did yesterday, I utilized a dashboard for operations. If you remember, we were looking at checkout services and things of that nature. Well, today I have a dashboard created around security views. Now, I might have created it. One of my peers might have created it. Who created it is kind of irrelevant, but we can easily share it amongst our team as well. But so what do we have here? Well, what we have here are some valuable security related information, and let's take a look at what it is. So the first thing, very straightforward, or not very straightforward, but pretty straightforward, is our user access for SSO and non-SSO login locations. So what we're seeing here is a worldwide map for the last 60 minutes of where users are logging in from. Now, why is this security related? Well, it might be important to know where users are logging in from and where they should be logging in from. If I am doing, I'm a company and let's see, what's an example? Sorry. A worldwide company, and I see somebody's coming out of Japan. And I don't think we're really doing any work in Japan right now. Now, if I have an employee who's working out of Japan or who's maybe doing some VPN testing related to Japan, then seeing someone pop out from Japan would make perfect sense. But if I'm not doing anything related to Japan and I don't have any work there and nobody's logging in from there and we're seeing people log in from there, then maybe we want to start to look at who is logging in from Japan. Should they be? Are they a bad actor? And starting to go down that rabbit hole, if you will. So we'll go through these maps we showed you yesterday, or very quickly, very, very quickly how to utilize them. We'll go in much more detail today, which will be just a cool thing to learn. Threat intelligence. So what I have here in the middle of the screen is the system looking at IP addresses and evaluating them for how malicious they are. What I have in this column is malicious confidence. How confident the system is that this is a bad IP. High being more malicious, medium being less likely to be malicious. And for this maliciousness, we are using outside data. We're not purely using Sumo Logic's data. We're actually going to be using CrowdStrike data. And so we'll talk about that a little bit later. It's actually, I think, the last lab we do, how we can bring in outside sets of data to help us evaluate what's going on. This one on the far right, excuse me, the suspicious login distances. So what we have here is the ability for us to look at where somebody has logged in and where they've logged in again. So this is relying on somebody logging in twice during a 24-hour period. And what's happening here is the system is letting us know, hey, this person logged in from the United States and logged in from Egypt in a 24-hour period. Now that's possible. Somebody could have logged in from New York and then gotten on a plane and flown over to Cairo and logged in from there in a 24-hour period, and that might make perfect sense. Or this might be a little bit more suspicious. And what we're going to look at later is the calculations that's used to determine this. Now, the calculation itself is a bit verbose. We'll get into that a little bit later as well. But the idea behind it is really kind of helpful and kind of cool in that we can see where somebody logged in from, where they logged in from again. Is it physically possible for them to travel that span during a specific time period? If it's not, maybe we start to flag that, and that's what we'll get into a little bit later. Let's see a couple more charts on here. Let's see. Certainly this one's pretty straightforward, and it's showing firewall traffic. So bytes sent, bytes received. These peaks might be concerning to us. These might be DDoS attacks or something like that. Well, bytes received. But this could be concerning. It might not be, but we're starting to get that information. Now down below here, we have this similar information, this traffic volume, but here we're using the outlier operator. And we talked about this yesterday, where it's allowing us, or actually I take it back, it's allowing the system to start to determine what is normal, what is acceptable, what isn't. And so what we're starting to see here is over the last 60 minutes, let me get my mouse kind of out of the way, there's been 4 times those pink triangles where the firewall traffic volume is higher than expected. Now, why is it higher than expected? Well, we could start to dig down that rabbit hole again, but this is what the information is telling us. All right, so that's a quick understanding or quick overview of the dashboards that we're going, or some of the more inspiration for the dashboards we'll be creating a little bit later. Of course, as mentioned earlier, any questions, go ahead and ask them in the chat. Matt and James and Stefan will be here later as well. So we've got a pretty full house on helping us today. So feel free to shout out there. But let's go ahead and let's get into the labs. So as we did yesterday, we're going to log into our training environment. If you've logged in before, you kind of already know the deal. You can use the same number you used previously. If you haven't, you're going to go ahead and select a 3-digit number. So we're all going to go to service.sumologic.com. We're all going to log in as training plus analyst, number, but you're going to select that 3-digit number. And once you've selected it, as Chris is already taking the lead, specifically more once you log in successfully, go ahead and post that number. If there's overlap in the numbers for today, it doesn't matter either. Yeah, today it really doesn't matter, but we like to know that you're logged in with that number. So I'm going to go ahead and log in as well. Actually, I'm going to log out of this account and log in. So we're all logging in. And if you're in, just wait for me, I guess. Cool. And then the other thing, let me give you the labs. Let me provide a link to those. So I'm going to paste those in the chat as well. So hopefully you can get those. So ideally what you have is you've logged in. And so you have this tab, this window open. And then you have the hands-on labs. So go ahead and wait just another moment or two for you all to get in. If you need help, let us know. That's why we're here. I'm going to go ahead and close a bunch of these tabs because I don't need them. So I'm going to close actually all the tabs so I can just kind of start fresh, if you will. All right, so I'm going to go ahead and continue. I think we're good. Yeah, I think we're good. So let's go ahead and continue. If you need help, like I said, please do shout. All right, so what we have here is, or are, our hands-on labs. And what we're showing in the front page, I mean, if you're welcome to read this, it's kind of some of the stuff I went over already, maybe a little bit better explained. But what we see here are some various just dashboards and views of compliance information, as it says here, the global view of security threats and out of the box app information, and just a lot of cool different stuff in there. And what we're going to do today is we're going to kind of replicate this security overview that I showed earlier. Now, we're not going to replicate it completely. We're not going to do every panel, but we're going to do enough to get the idea across. So let's go ahead and well, you don't have to click on the introduction. You can go straight to lab 1. So ideally, just once again, just to kind of pause here, make sure we're together. We're logged in. We have Sumo open. We have our labs open, and we're on lab 1, ideally ready to go. All right, so let's go. So lab 1 is monitoring user activity. Now these labs, specifically this first one, is a bit of a bear. It's 23 steps, 21 steps. We're going to go through them all. It is a long lab. Just more of a heads up than anything. All right, so what do we want to do here in lab 1? Well, what we want to do is monitor user activity. Now, maybe you don't know why monitoring user activity is helpful. I kind of feel like everybody does at a high level, but as a reminder, monitoring user activity can help you understand what your users are doing in the environment. Now, for this example, we're going to be using AWS data. We'll be using AWS data for many of the examples today. Purely just well, one of AWS data is quite popular, but just a creative choice. We could use anything, just this is what we're deciding to utilize. It's common. So what we're going to do in this lab is we're going to create a query that's going to look at the top 10 AWS activities. We're also going to learn how to do some basic parsing with JSON. We're going to make a visual chart. We're also going to take that chart and turn it into a panel in a dashboard. And as it says here, by the end of lab 6, we're going to create 5 panels of a SOC dashboard. So at the end of today, you're actually going to walk away, or at the end of the morning, walk away with your own SOC dashboard. Now, if you actually want to take it with you or not, that's up to you, but we're going to go through the steps either way. So let's go ahead and let's start rolling here. So lab 1, step 1. So in this case, we're using, as mentioned, AWS data, and more specifically CloudTrail data. Yesterday, we used Apache data, and today we're using CloudTrail data. So what I'm going to do is I'm going to grab this whole query in all 4 lines in step 1 and paste them into a new query and talk through each line and explain what it's doing. So ideally, you'll go ahead and grab all 4 lines. You'll go to Sumo Logic. You'll do a new log search. You'll paste the 4 lines in. Now, what I'm going to be doing a lot today, I didn't really do it much yesterday, is I'm going to use backslashes here to comment off this line. And when I comment that line, it's as if the line does not exist. So when I run this query right now, it's only going to run the first line because I want to show you the first line and what it does, and then show you the second line, and so on and so forth. So let's run this. So what I'm presented with, and what you should be presented with, is log messages like we saw yesterday. My log messages are down below here. These log messages look a little bit different. Hopefully you remember what the other ones looked like yesterday. If you don't, that's okay, but they do look different. The reason they look different is they're formatted differently. CloudTrail messages are in what's called a JSON format. This is not a Sumo format, it's a standardization, and that's the formatting that's chosen, is JSON. And so as a result, it puts these log messages in, just it looks a little bit different. We still have similar information. We have date and time information. You remember with the Apache information, we had IP addresses. So we have data, we have fields, we have values, but as mentioned, it's formatted a little bit differently. Now, what I'm going to do on the second line is I'm now going to take one of these fields and rename it. So the field I'm interested in is user identity dot username. And the dot here represents a nested field. So what I'm trying to have the system look at is user identity. And then actually it's under here. Where is it? Here it is. Sorry. So I'm looking for user identity and then looking for username. And what I want to do is I want to retrieve that data, this value here, and I want to give it a new name. I don't want to call it user identity.username. I want to call it actor. And so now when I click start or search, I now get basically the same data I got previously, but now I have a column called actor, which is having or showing that username. And so now I have usernames. Now I'm going to do a similar action or feature for event type. I'm going to take the field that Sumo, that AWS calls event type, and I'm going to call it event underscore type. Now, once again, I have a new field with values. Remember, I'm trying to see what users are doing and what they're doing the most of. So who the user is and what activity they're doing a lot of. And so that's why I need the actor or the user and the event type or what they're doing. Now what I'm going to do here is take the source IP address right here, and I'm going to call it source underscore IP. All right, just looking at a question here. The question is about navigation. Why don't you need to navigate down the JSON tree to get the field? So I don't. So I am actually navigating down the field, the tree a little bit. Some of these fields are at the top level of that tree, and some are down below. But with my parsing, and that's what's occurring here, this is parsing out this data. It's automatically bringing it to the top level for me. So now I have these values, fields with the appropriate values in them. All right. And as it describes here, we can also parse using the UI. So we could actually highlight, I guess we could do it. I guess I could show it real fast. Let's see. But kind of what was Sonia's asking a little bit is we could also parse the information by saying, to do source IP. Yeah. Oh, there it is. It's parsing it right there. So I could go ahead and parse it that way as well. Like get back to where I was with. Okay. So, and let me. So we have our first four lines. All right. So, and then, the last field, line we want to put in is this line right here. So what we're doing is we're taking the field of event name and we're renaming it to event underscore name. And we'll show you why we're doing that a little bit later. It sounds, well, it's not repetitive. It's calling out that field specifically, but we'll use that field a little bit later. All right, so as it says, congratulations, we did the first 5 lines of code. Now what we want to do is we want to put a line that looks kind of strange. We want to put this line that says where event type or where underscore event type matches event underscore type. So I'm going to copy it in because the lab tells me to. And so I'm blindly going to do it. Now, why am I entering this line? This line seems to be repetitive. Like I said, it's saying where this equals this. What we're going to do with this is we're going to turn it into a parameter. And what it's going to allow us to do is turn that into a field that we can enter values in, or we can retrieve values from, and have the have a parameter displayed for us. So let's take a look at that because that explanation wasn't too good. So what I'm going to do is I'm going to highlight the word event type, specifically the second one here. So I have my line here. I'm going to take this second event type and highlight it. And when I do, come on. When I highlight it, I should now have this feature over here that says create a parameter. Unhighlighted, I don't have it. highlighted I do. When I have that highlighted and that option of create a parameter, I'm going to select create a parameter. And what it's going to do is bring this parameter setting dialog box up for me. And what I'm going to do is really just mirror the result, mirror the entries I have here. So I'm going to take that parameter setting and I'm going to call it event type. So very simply, I just changed that parameter name from the default of parameter 1 to rename it event underscore type. And I click save. What this now gives me is the ability over here in this parameters box or section to specify what event type I want to look for. If I just want to look for AWS API calls, I can now do so pretty easily. So when I put that event type in, I get just those specific events types. Now, I want to make sure something's in there. So I need to at least put a star, because if I have nothing in there, it's going to look for an event type equal to nothing, and that's not going to exist. So it's important that we do have a star in there to represent the wildcard, to represent the fact that we want to retrieve all results. We set up a filter, but we don't want to filter anything yet. We want to retrieve everything. So I hope that makes sense. All right, so back to the lab, just to make sure we're kind of all together. We should now have the parameter window popped up. And once again, we should specify that wildcard in there. Now, what we're going to do is do something pretty similar. I'm going to grab the next 4 lines, but I'm going to go through each line one by one. So I'm taking these next 4 lines, I'm going to paste them in, but let's go one by one. Okay. Now, line 7, we're doing a very similar feature where we're saying where event types matches event type. We're doing where actor matches actor. And the reason we're doing this is for the similar idea that we want to be able to search on the actor or search on the user. So by doing this, I can now do so. And so now I can specify a specific actor or specific user, or I can use the wildcard to say retrieve everything. And that's what we want you to use right now. But now I have these parameters that I can start to utilize. Now what I want to do is start to count my data. I have my data here. I have my users. I have what they did. I have what IP address they did it from. But now is the chance to take it and aggregate it and put it all together, because remember, my goal is to find the top 10 activities that are happening most frequently. So what I'm going to do now on line 8 is count my data. I'm going to count the actor and the event type and the name. And by doing so, it's going to start to put it together. It's going to give me the aggregates tab. And I now start to see information. Now I have 25 rows here, 6 pages. My goal is to get to a top 10 list, but for right now, I'm at least starting to get there. And so what I now see is Kevin did an AWS API call 3 times in the past 15 minutes. Goja did an AWS API call 8 times. And I'm starting to get that information. There was a question about creating a drop-down where all possible values are listed. Yes, we're going to do that later. So great question, just a little too early in our labs, but we're getting there. So what I have is, like I said, I have my users, what they did, how many times they did it. Now I want to take that and start to shrink it down. I just want to find the top 10. I don't want all 120 values or possibilities. So I'm going to say take the top 10. The top 10 what? The top 10 actors or users, and do it by event type and count. And so now what I start to get is my users, what they did, and how many times they did it. Now what I can do here is I can transpose this data, and we did this yesterday, to take this and turn it into a kind of an Excel spreadsheet. Because what makes this a little confusing to read, not too bad, but here I have Kevin. He did a bunch of AWS console sign-ins, and he also did a bunch of AWS API calls. Now, by transposing, this data might be a little bit easier to view. And so what I want to do or want to show here is that transposition. And what we get now is, like I said, hopefully a little bit easier to understand. We have our users or our actors. we have the events that occurred during that time period, and we have the count or frequency of those occurring. And so now I could, start to do something with this. Now, once again, why is this? Well, actually, let's keep going. This lab goes further. So, all right. So where we should now be is actually all the way through lab 7. Excuse me, lab 1, step 7. So hopefully you're at this stage where you have, like I said, pretty similar. The query wants us to do it for the last 24 hours. So I'll go ahead and respect that. To change the time, in case you didn't know, click on the current time period and then select the one you want. And now my numbers are higher, of course, because it's a much larger time period. All right, so next we're going to go ahead and take this table and turn it into a chart. So as described yesterday as well, by default, we're in this tabular view, but maybe we'd prefer to present this data in a more graphical view. Bar charts, column charts, line charts, pie charts. For now, I think we encourage you to use the bar chart, but if you want to be crazy and use the column chart, you can as well. It doesn't really matter too much. Now, what we can do, and I don't think I showed this yesterday, is we can modify our charts. We have a few different ways to do it. In this case, what we're going to do is we're going to go to the chart and we're going to go to the gear icon. And in here, we have different settings. One of them is changing the properties, which is changing the color scheme. Might sound like a minor thing, but it's something that was highly requested and important enough for us to add. And so, some organizations like to use different colors. You also have the ability to change many different things in here. Change the legend, for example. Maybe you want to move it from the right to the bottom. You can do so. And other settings in here. We'll go over some of them a little bit later as well. Now, once you have it in the chart that you prefer, and in this case, we're encouraging you to use red, but I'm going to be a rebel and use purple. We're going to go ahead and now use a lookup table. And what we're going to do here is we're going to create our parameters from values that exist already. So this was a question that was just asked a few moments ago, and we're actually getting to it right now. So what we're going to do is we're going to take our parameters and we're going to create a lookup table and use that lookup table towards our parameter selection. So let's go ahead and do that. And to do so, we're, as before, kind of going to follow the steps. So what I'm going to do is I'm going to go ahead and open my event type and choose Manage Parameter Settings. When I do, I go to the screen that I was on earlier where I actually created the parameter. But I want to use an additional option here, which is right here. It's kind of not hidden, but might not be obvious. So I want to decide, how do I want to provide values for this parameter? How do I want to have a list of autocomplete values created? Do I want to do some text entries? No, we could, but that's not what this is all about. What we want to do is we want to use a lookup table. What we're going to do here is we're going to use a lookup table that has already been created. So what we're doing here is we're saying I or somebody in the company has created a list of shared event types. Basically, they've created a list of event types and they're sharing it. And what we're going to do is we're going to reference this lookup file and utilize it. So to do so, it's really kind of easy. We just reference where it's located. So we're going to go ahead and go to lookup. We're going to look up the file. And so the file is going to be located at shared/event_types. We're going to select the field for the values. And so the field we want to use is called event type. And I think that's it. Yep, and that's all. Once we have that saved or entered, we're then going to click save. Now, if all goes well, fingers crossed, it's going to take a moment or two. And now what should happen is if I go to this event type, I now have those event types available for me. And so what I'm doing is I'm now, kind of as was asked earlier, using a list that's already been pre-processed, if you will. And this is an example of utilizing a lookup table. We're going to discuss other lookup tables later, but you have that ability in Sumo Logic. It's not something we really talked about yesterday, but it is something we're talking about right now. And so that's a helpful feature. And we'll talk about those a little bit later of where those can be helpful. So where we should be right now is we should be at lab 1, step 14. And now what we're going to do is we're going to create our dashboard. So as mentioned, we're going to create a SOC dashboard that's going to take many of these panels we're creating today and put them in one place. So to create it, we're going to go ahead and click on Add to Dashboard. We're going to then give the panel a name. So top 10 user activity. We're going to create our own dashboard for today. So we're going to create, I think we want you to call it, come on. There we go. Call it SOC. I'm lazy. SOC _234. That's good enough. And then create new dashboard. And once again, we're going to use the old UI. So make sure you get that. If you're getting errors, that might be why. So we're going to use the old dashboard, and then we're going to click Add. And what we should get is we should now get a new dashboard with a new panel, being that panel that we just created. And now we have a SOC dashboard. And now we're going to add on to it. All right, cool. So let's make sure, I think we're good. Oh, no, we're not done. I forgot. There's so many steps to this lab. What we want to do here is we want to go ahead and enable our filters, because what we're going to do later is we can start to utilize these filters. So here's the filter icon. And so what we can do is we can start to filter. So for example, if I just wanted to see Mike's user activity, I can type Mike. And now I just see his user activity. All right, so where we should now be is we should be in our dashboard with our filters available. And then we're done. Okay. There's a couple quiz questions, so we'll go through these. Yeah, we'll go through these. So these are true, false. Feel free to answer in the chat. No prizes today, unfortunately. So the first quiz question: JSON field equals raw, source IP address equals, or as source IP. These are really not great to read. True or false? Does that extract the source IP address and all subsequent values as appearing in the incoming log messages? So, true or false? So that's going to be true. We're taking that field of source IP address and we're renaming it to be source IP, but it will contain that value. Number two, this one well, yeah, let's do number two, sorry. The double curly brackets enclosing a variable label are used to create parameters. True or false? That's true as well. And so we saw that as an example right here in step 12, where we're where the highlighting is, those curly brackets represent that. Now you saw for the first one, for the event type, I actually highlighted the word event type and right-clicked on it and went to manage parameter settings that way. I could have also just typed the curly brackets straight away and it would recognize it as a parameter. So long story short, true. Question number 3, I use the setting icon in the message tab to change the color of the bar graph. And that's false. So a little bit of a trick question. We did use the settings, but it was in the aggregates tab. When we're in the messages tab, we just get raw messages. Aggregates tab starts to give us those chart options and then gives the ability to also start to change the color. So it was in the aggregates tab, not the message tab. So, all right, cool. I think we're all together. Let's continue here. Now, lab number 2 is going to be about geolocation. We touched on this yesterday, but we're going to go a little bit more deeper because that's what today is all about. So previous example, we did monitoring user activity. Now we want to see where users are logging in from. And so once again, we're going to use CloudTrail data, and we're going to look for multiple IP addresses. So, same idea. Let's grab this. So I'm going to go ahead and grab the first line. I'm going to do a new query or new log search. I'm going to paste my line in. I like to do that just to make sure it works, and it does, as it should. Now I'm going to go back and grab those other lines. Now I'm going to grab these lines. As it says, these are pretty similar to the first lab that we did. And so I'll grab them, I'll paste them in. I'll go line by line just because, but it's not really necessary since these should look familiar. So once again, we're grabbing the CloudTrail data. We're looking for that user identity and username and calling that actor. We're looking for that event type. We're taking that source IP address and we're calling it source_IP, just because we want to. We could call it whatever we want. That's what I want to call it. Now, the other thing we're doing here is we're looking at console login and we're looking at the result here. The reason we're going to start to look at the result is we can start to see when did somebody log in successfully and when did they not log in successfully. And for today's example, success is going to be important. And so we can start to pull that as an attribute, as a field. So once again, as I ran it, I should now get the actor, the event type, the source IP, and the result. Now I'm going to go ahead and utilize my parameters and filters. Now in step 4, I'm going to use a where statement. And the where statement I'm using is saying, look for actor and look for event type. And look to see if they're empty. And if they're empty, don't retrieve them. So I'm basically saying only bring back results where I have an actor. If the actor is not empty, I want that. So it's a way for me to confirm, bring back results that exist. If there's nulls or blanks, I don't want those. I want actual results. And then I'm going to create my parameters. Once again, as we just talked about, I can go ahead and create my parameters using the query language. I don't have to go ahead and right click on it and go to manage parameter settings. However, once I do have my parameters defined, I do need to specify those stars, because if I don't, I'm going to get no results back, and that's not what I want. I need results. So I want to go ahead and put the parameter as, once again, that wildcard. And so that's what we're telling you to do in step 6. Now in step 7, we're going to start to use this geo lookup. Now we used this yesterday, but we're still going to go over it today. Not still, we are going to go over it today and explain what this is doing. Now, what we have here, we have IP addresses. And what we can do with these IP addresses, if we can associate them with a geographic location. Those IP addresses are associated with a physical spot in the world. And what we're doing here in line 11 is looking up that geographic information. Now, Sumo Logic, we're really great at logs and metrics and security and other stuff. We do great. Geographic information is not something that we do. It's not our expertise. It's not something we want to do. It's something that other companies do better than us. And in this case, there's a company called Newstar that does a really good job with this. And so when you go to a website and you get local information, it's often based on the same technology of taking your IP address, seeing where it is in the world, and then providing usually advertisements to you, but maybe local sports and weather content and things like that. And so that's what's happening here. And this last line is doing or using this lookup table. This lookup table is housed at this location of geolocation. We looked at a few moments ago the lookup table for those shared event types, and that was located at shared/event types. And so there's other places to save lookup tables. And now the way this is looking things up is it's using this line, once again, line 11. And if you read the line going from right to left, it's going to be a little more clear, or I think it will be a little more clear. What I'm doing is I'm taking the source IP address. So I'm taking this IP address and I'm looking it up and comparing it to the IPs that exist in the geolocation table, that Newstar data. If the IP address matches with the physical location, I'm going to retrieve it back. Now, what am I going to retrieve back? I'm going to retrieve the latitude, the longitude, the country name, the city, the region. There's actually other information I can retrieve. It's all pretty similar, but I can retrieve other, but this is what I need. So now when I do a search or a start, I should now have my user, the event activity, the IP address, but now I also get the city, the country name, the latitude and longitude. That's going to be important when we create a map, the region if appropriate. And now I'm getting this geographic information. Now what I want to do next, and this is step 8, is I want to count this data. I want to aggregate this data. Right now, I have a list of Ankit did something from the United States, Goja did something from the United States, but I need to put this all together. I need to aggregate it to get some results out of it. Looking at these raw log messages, well, they are essentially raw log messages that have been parsed is helpful, but aggregating is going to be even better. So what I'm going to do here is I'm going to just do a new line. And in this new line, I'm going to count the actor, the IP address, latitude, longitude, country name, and event type. I don't actually need to count all this. This is kind of a little bit of overkill, but it's still, it's fine. it's not going to be a problem. And so what I'm now getting is my aggregation. Now, since I get aggregation, as a reminder, I can look at this data in other formats. I can just look at it as a table of data, but I'm going to have another option that I'm going to show in just a second. So where we should now be is we should be just about ready to go to step 7. I just want to make sure we're all kind of together. Now, what chart version do we want to look at? We could look at a bar chart. We could look at a line chart. Once again, it may not make sense, but we can do so. But what we can do is we can take advantage of our mapping capabilities. The reason we can do this is because we have a latitude and a longitude. And what I'm going to do when I click on the mapping icon is very simply, the system's going to do it for me. I'm not doing anything. It's now going to map those latitudes and longitudes. And so now what I see is where my users have logged in from. In this case, I'm in the last 15 minutes. I probably should do the last 24 hours, but it doesn't really matter too much. But now I'm starting to see that users have logged in from wherever. And now I have a map of, once again, geolocation. And as mentioned earlier, if somebody's logging in from China, that might be kind of concerning. In today's world, if somebody's logging in from Russia, that might be concerning. It might be somebody VPN testing as well. We don't really know, but we can start to ask those questions. All right, so let's go back to lab 2. We now have our map. And so what we want to do is take this map and add it to our dashboard so that we now have 2 things on our dashboard. So to take the map, we're going to go to add to dashboard. We're going to give it a name. I'm really not feeling very creative. I'm going to call it map. And I'm going to point out or locate my SOC dashboard. So that's SOC 234. I'm going to click add. Now I'm going to get this warning about this filter already existing. And this is it's one that's good that it's helping me. It's letting me know that it has conflicting filters because I created that filter earlier and I want it to have conflicting. So in this case, I just want to add panel. I don't want to rename it. It's a good message. And so now I have both panels. Now what I can do, as I was describing with those filters, let's say I just want to look and see where Mike has been. Now what I'm seeing on the left-hand side of the screen, once it loads, is what Mike did over the last 24 hours. And I'm seeing where he did it from. Now, if Mike is on vacation and these actions are taking place, this might be quite concerning. If Mike is been let go, this might be quite concerning. If Mike is, once again, VPN testing around the world, then this makes perfect sense. And this is where we start to kind of put that security hat on and decide, is this good? Is this bad? Is this legit? Is it not? All right. Let's see. Yeah, that's all for that lab. So a couple of quiz questions. So the first one, lookup uses the CrowdStrike data to provide latitude and longitude, true or false? So that's false, correct. For the latitude and longitude data, we are using NuStar, and it's spelled Neustar. And then we're using Mapbox for the map generation themselves. Question number 2, I can display a map without aggregating data, true or false? And that's false. So I can get geographic data without going to aggregates, which I'm trying to show right now. There we go. But to actually get that map, I need to go into aggregates. And to really get any visual component, you need to go to aggregates. And then I can use add panel to add to an existing dashboard. It's kind of a, not a trick question. I don't think we really looked at it, but let's take a look together. And so I can't do that. Well, yeah. I don't have that ability. So that's false. All right. Cool. On to lab 3. We'll take a break. Let's see. We'll finish lab 3 and then probably take a break. Maybe finish even lab 4. All right. So on to lab 3. In this case, also, under the vein of security, as today's all about, we want to look at top 10 number of failed logins. So why do we want to look at failed logins? Once again, it should be mildly obvious, but it could be representing the fact that a user forgot their password, or it could be somebody trying to hack their way into your network. And so what we want to do is start to take a look at those failed logins, and using Sumo, start to look at it with a different view and get some value from it. In this example, we're going to use some of the features we looked at already, We used time slice previously yesterday, but we'll use it again. Some other things, but let's start to go through this. So these queries are starting to get a bit repetitive intentionally. So once again, we're using CloudTrail data. We're using a bunch of fields to parse out these fields as we need them. So I'm going to grab the whole query in step 3. Do a new log search. Paste it in, last 24 hours, run it just to make sure I don't have any typos. And now I have my data. Now for this data, once again, this result is going to be important. This lab is looking at top 10 number of failed logins. If we didn't care if it was login attempts, that might be different. But in this case, having the value of success or having the value of fail is going to be quite important here. And we'll get utilizing that in just a moment. Now, once again, as we've done, we're going to go ahead and create those 2 parameters. And so we're doing those just by pasting that text in, getting those parameter fields created, and then putting stars in there to have a value so that, or all values so that we can retrieve something. All right. Now what we're going to do in step 7 is very similar to what we were doing earlier. We're going to go ahead and take the isEmpties again. So we're saying look specifically for places where there is data of an actor and event type. If there's not a value there, don't include it in the results. And we're going to specify of that result type again. So we want to specify that we want a result of failure because we're looking for failed login. So result is important to us. We're also going to specify the AWS console sign-in because that's what we want to look for successes or fails is the console sign-in. So now when I run this, what I should get, what I should get is data. So, and only failures. Now what I want to do, and it's still loading, last 24 hours, it's going to take a lot of time just to get all this data. Now that it's not a lot of data, it's just taking a few moments. But what we're going to do now is we're going to start to use our time slice. Because right now I'm looking at, or will look at once this is done, the aggregation of 24 hours. Now, do I want to see how many times somebody failed to log in during a 24-hour period? Maybe. But what I want to do is I want to get more granular. What I want to do is I want to look at a 1-hour period and see how many times they failed to log in a 1-hour period. over a 24-hour span. So I'm going to grab this whole portion in step 8 just to save me a little bit of copying and pasting, but I'm going to go line by line. So in line 13, we're adding that time slice. We're saying we want to break up our data into 1-hour slices. If we wanted to look at our data in 2-hour slices, we could, but 1 hour is very common and makes sense because our time periods are common. And then I'm going to count the data. So what I'm doing is I'm now counting by the time slice, by those 1-hour periods, by the actor, what they were doing, et cetera, et cetera. Since I'm doing count, I'm doing aggregation, I'm now going to have that new tab of aggregates. And now what I start to see are these 1-hour time periods. Now it's going to take a few moments to load, but I can still talk about it. So for example, in line 1, we see that Kevin from 2 p.m. to 3 p.m., this is a 1-hour time period, failed to log in 1 time. From 10 p.m. to 11 p.m., Ankit failed to log in 1 time, and so on and so forth. Now it's taking all this data and aggregating it. But once again, we don't want all the data. We just want the top 10. So rather than getting about 75 rows, let's get just 10. So what I'm going to do here is I'm going to say take the top 10 users, and do it by time slice and by event type and by these other groupings. So what I now see is, it's still loading. That's just going to take a moment. Looks like it's just about finishing up. But once it's done, or even if it's still processing, I can still go ahead and add it. Now I can add this to our dashboard. So now I have the top 10 users with the highest counts. And now this might be helpful for me. So now I'm going to take this, add to dashboard, call this failed logins, reference that SOC dashboard I'm using, that's SOC 234, click add, and essentially be done with it. And add panel, because we're going to reuse those parameters again. And so now I should have my third panel start to show up in here. Cool. Let's see, let's do quizzes here. So first quiz question, adding a wildcard in the parameter window means it will filter out everything. So bit of a, so it's false. The wording's a little tricky there. So we'll actually include everything. Question number 2, time slice groups my incoming logs into chunks of time. True or false? So it's true, the wording in here I don't like, because the incoming logs, it's actually logs that have already arrived, but it's true. It groups your logs into time. That's close enough. The word incoming should really be removed from here, but it's still true either way. And then question number 3, the following code where is empty actor filters out logs that do not have an actor. True or false? Correct. True. Cool. Good job, guys. All right, let's do one more. Yeah, let's do this one. Let's do one more lab and then even less to come back to. Now in lab 4, what we want to look at is the idea of brute force attacks. What a brute force attack is essentially somebody trying to log in. Sorry. So they'll attempt to log in and they'll repetitively use credentials to try and figure out a password. So they'll take a login and use password 1, try password 2, password 3, and use many different logins. Now, the way we can start to detect this attempt is by looking at our CloudTrail data and looking for a high number of failed login attempts within a period of time, because that could represent the fact that somebody was not able to get in, not just a user, but that a systematic process was taking place. If somebody forgets their login 2 or 3 times, all right, it's just human error. If we see somebody forgot their password 60 times in an hour, well, that's kind of a little weird. And that's what we can start to reveal with our data. So in this case, we're going to go ahead and do so. The first chunk of this lab, very repetitive. So in step 3, I'm going to grab that whole portion and just grab it and paste it into a new query. Run it once again, just to make sure it works. I'm going to set it to the last 24 hours because that's what I was told to do. And now I have my data. Now, once again, we're going to reuse, or not, well, yeah, reuse these parameters. So I'm just going to paste those in. Once the system recognizes them, put those wildcards in. And now we're going to get into step 7. What we're doing in step 7 is we're going to aggregate our data over time, and we're going to use if conditionals to do so. So let me go ahead and grab the whole chunk here in step 7. And once again, let me just talk through it. I think that's better. Okay. So okay. So what I'm doing here with the time slice is, once again, taking my data of 24-hour time period and breaking out into 1-hour time chunks, seeing what occurred from 10 to 11, from 11 to 12, 12 to 1, so on and so forth. Now, what I'm going to do here is I'm using a tally system, and I'm using if conditionals to do so. What I'm going to do is I'm going to have the system look at the result. Remember, we're concerned about the result. The result is either going to be success or fail. Success representing the fact that somebody logged in successfully, fail meaning they were not successful and failed to log in. And so it's kind of binary in that way. They either logged in successfully or they didn't. What I'm doing here is I'm creating a field called success count. And the system's going to look at the current value of success for each log message. And based on if it sees a success or not, true or false, it's going to tally a 1 or a 0. So let's take a look at that. So when I run the query with line 10, I'm going to have a new column in here called success count. And the value here is going to be 1 or 0. If the person logged in successfully, the value is going to be a 1, meaning true. If there was a failed login, let's see if I have one here. I don't want to kind of waste time looking for one, but if there was one handy, it would be valuable. All right, well, you can envision, and you can probably find one yourself. If you have a failure, it should have a 0 in the success count column. Now, that being said, we're going to do a very similar thing on the next line, except this time we're going to look at failures and we're going to count for failures. If we see a failure, we're going to tally a 1. If we see a success, we're going to tally a 0. So let me rerun this again. So now each log message has a failure count and a success count. If it's a success, it's going to have 1 in the success count and a 0 in the failure count. If it was a failure, it would have a 1 in the failure count and a 0 in the success count. Now, why did we do that? Why did we break them up in that way? What we're going to do now is we're going to simply add them up, and we're going to do it by time slice. So I'm going to sum my data. By summing it, I'm aggregating it. I'm doing math against it. And what I'm now going to start to see are periods of time where I can compare. Here, from 4 a.m. to 5 a.m., Jay Schmo logged in successfully 10 times and failed to log in once. Here, Mike, from 1 a.m. to 2 a.m., logged in successfully 12 times and failed to log in 0 times, which is good. He logged in successfully every time. Now, what I'm going to do here is I'm going to modify this a little bit. Remember, the goal of this lab is to look for failed logins. In this case, successful logins is not the goal here. Successful logins means someone logged in successfully. Maybe legitimate, maybe not, but that's not the conversation. The conversation is, did they fail to log in multiple times during a time period? And so what I'm going to say here for line 13 is I'm going to say, for each time period, only show me where failure is greater than 0. In this case, where somebody logged in successfully every time, that's not what I'm looking for here. I want to look for failed logins. So in this case, don't show me where failure is 0. Show me if it's only greater than 0. And so by doing that, when I run line 13, I am now going to exclude some of my results and filter them out and only now have values or data that has at least one failure. Now, what I can do in this equation is then not actually correct, but for today, it's close enough. What I could do is now I can start to create a failure percentage where I could say, take the failures, take the successes, divide them, multiply by 100. And now I can start to see a failure rate that's good and a failure rate that's bad. Or not good and bad. That's not really a problem. Let me just hide this. Let me, there. I just wanted to show this data. So what we now see here, and like I said, the equation is actually a little messed up, but now I can start to see that somebody has logged in successfully here, failed to log in here, and I'm starting to get a percentage. And based on that percentage, I can see, is this good, is this bad? Now with these values, we only really have low amount of failures, so it's not really exciting. What would be better data, and I just don't have the data to back it up, would be, is this, if this showed success 1 and showed failure 100, that might be more indicative of a brute force attack. None of these are just very scary. The most amount of failures is 3. So it's just kind of good, but it doesn't show the use case as well as we'd like. So, all right. So let's go. Let me just see. I think that's it for this panel. Yeah, same idea. So let's go ahead and now add to dashboard. Give it a name. I'll call it brute force. Try and spell it sort of right. And then stick it in that SOC dashboard again. All right, cool. So what we should have now is our dashboard should have 4 panels. And this will be a pretty good place to take a break. So what we'll do is we'll take a break, probably another 7 or 8 minute break or so. We'll come back, we'll do these 4 labs. They won't take that long. And then we'll do the exam and continue. So let's get that timer going. We'll do a 7-minute break. Actually, let's do 8 minutes. We'll come back at 20 after. So I'll give you that extra minute. So once again, we'll go take a break, grab a snack, beverage, what have you, come back, do some more labs and take an exam and then do more labs later. So have a good break and speak to you all in a few moments. Thank you. All right, everybody, welcome back. Hopefully you had a good little break or a snack or what have you. Going to continue where we were. So once again, we had just finished lab 4, and lab 4 was going over the idea of brute force attack using our if conditional statements. And what we're going to do is we're going to jump into lab 5 now. Now, lab 5 is a bit of a doozy. Let me elaborate here. What we're going to do now is we're going to detect a land speed violation. And so this is the example I mentioned earlier, where imagine a user logs in from Australia, and specifically from the Australia, and then 3 hours later, they log in from Brazil. Now, physically, that's not possible. And we can have the system start to detect that. Now, what we're going to do is we're going to go through the formula that's used to detect that. It's quite in the weeds. It's quite technical. It's quite verbose. It's probably overkill. So for this example, it's not necessary that you understand every single step, but at a higher level, you understand what's going on. And we actually have, or if you've already scrolled down, you see there's a bit of a chart to kind of describe what's occurring here. So let's give it a shot. So what we want to do is we want to, the query flowchart is kind of describing the steps that we're about to do. So what we're going to do is we're going to select our source category like we've done before. We're going to parse out the user and the IP address. Remember, this is going to be based on some geographic information, so IP address can be helpful here. We're going to filter out null IP addresses because we want only actual IP addresses. If it's a blank IP address or null, that's not what we want. We're going to then create, as it says here, the start of when a user logs in and examine the times each user has logged in from the IP address. So if a user logs in one time during a 24-hour period, that's not what this is about. This is about seeing that user log in twice from an IP or from a location during a period of time. As a result, we're going to filter out those single logins because we don't want single logins. We want logins that have at least that are multiple logins. Somebody has logged in at least twice. Here, it's going to get, this is where it kind of gets just mathy and really nerdy, is we're going to take the IP address, we're going to convert it to a decimal format. We're going to do a geo lookup of each IP address. So to see where that individual is logging in from using that geographic information that we talked about earlier. Then what we're going to do is once we figure out where geographically those IPs are located or where that user is located, we're going to calculate the distance between the two logins using what's called the Haversine formula. The Haversine formula, not a Sumo logic thing, is the idea, and we'll get to this, but the idea of on a map or on a globe, 2 different points. Since the world is spherical, hopefully that's not news to you. You can't just do a straight measurement. There's angles and all different things. And so this Haversine formula takes that into account. And so it can start to tell us one location in the world, another location, how far apart they are in kilometers. And then we can start to determine, is that physically possible? Could somebody have traveled from Australia to Brazil in that time period? No, they couldn't. That's curious. Let's flag it and then dig into why it's occurring or what happened. So that's the lab. Let's kind of grab these pieces. Once again, I'm going to go through it. Well, I'm going to go through it pretty thoroughly, but let's do so. So in the first line in step 2, once again, do a new log search. And so what I'm doing here is I'm grabbing my data, CloudTrail data, and I'm parsing out these IP addresses and users. In this case, I don't know why we should be consistent. I think we change it later, but in this case, I'm calling the user identity, that username, I'm calling that a user. Previously, we've been referring to it as an actor, but I think we rename it a little bit later. Next, what we're going to do in step 3, once again, very in the weeds with the query itself, but what we're doing is we're filtering out public IP addresses, and we're starting to create a start point of when the user logs in from that IP address. So what we're doing is saying where user matches actor. So we're once again using our actor field. I thought we used it at some point, and we're using it right here. We're saying look for a public IP. This does not work if it's not a public IP. If it's a private IP address, that does not work. Quick question question was about no drop. I'll reference that real fast just since it was asked about. What this no drop means is retrieve this data. Normally, without a no drop, it would only retrieve this data if it's a perfect match. But with the no drop, it's saying try to grab the data. If there's data, grab it. If there isn't, retrieve the result anyhow and don't drop any other results. And so it's used, it's kind of a weird spot for it here. We use it in other places. If you take our search mastery class, you'll see it. So that's just what it is in a nutshell. Matt, I think, is probably going to type a more elaborate answer maybe. Now, what we're doing right here is we're starting that message time, or starting that time 0 essentially. So we're saying, okay, somebody logged in, let's start that login time, and then we're sorting it. So when I run this, what I get down below is I get my user or my actor. I get the IP address they logged in from, and I get the login time using, I think this is epoch time. Somebody will correct me, but using fancy time. So that's what I have here. Now what I'm going to start to do is take, well, it says in here what I'm going to do, but I'm going to go ahead and filter on users with only a single login or the latest event and avoid null messages. Basically, I just want to look for those users that have logged in more than one time. If they've only logged in once, that's not really helpful for me. So once again, don't need to get too in the weeds with the IPv4. It's really just kind of in the weeds with backshift and things like that, but we're using them here, so don't need to get too ingrained with what they specifically are doing. But on a whole, it's the idea that we're filtering our users. Now what we're doing, and this is also very in the weeds, this is really the last step that's in the weeds, is converting our IP address to a decimal and then converting them back to an IP address. And when we do that, what we start to get down below is it looks quite busy, but what we're starting to see is here's Siraj, here's the IP address he logged in from and the time he did it from. Here's another IP address that he logged in from and the time that he did it from. And what we're now going to start to do is start to calculate those distances. And so that's what's occurring in step 6, is we're starting to do that geographic location lookup. We're starting to take those two IPs, because in this case, if there's only one IP, it's not really relevant. We need more than one IP, more than one login to have occurred. So what we're doing here is we're saying look up the first IP and the geolocation it came from, and then look up another IP. Call the first one latitude 1, longitude 1, call the second one latitude 2, longitude 2. And now down below in my results, there's a lot of results, there's a lot of information in here, but what I'm now starting to see is Saranj here logged in from Brazil and logged in from the United States. Now we haven't figured out when he did those, although we do see it in these previous logins, but we're gonna have the system start to calculate, was this possible? But this is just telling us that. Here, somebody logged in from the UK and the Netherlands. Here, Sweden and China, et cetera, et cetera. Now we're going to use the Haversine formula. And so what we're going to do is have the Haversine formula take those latitudes, take those longitudes, and calculate the distance in kilometers between them. Now this Haversine formula, I don't expect you to probably ever use it again, but it is helpful in this use case and makes it kind of interesting. So once this is done running, and I should do last 24 hours, but I'll keep it shorter for now. I'm now starting to see the distance in kilometers from where this individual might have logged in first and then secondary. Now what I want to do is calculate the speed that a user would have had to travel in order for this to happen. So the way I'm doing it here, once again, getting a little, not too fancy. But what I'm starting to do is I'm saying, take the login time and subtract it from the other login time and figure out in delta hours how long, how many hours apart they were or are, those two logins. Then look at the distance in kilometers to start to get a kilometers per an hour. Now, when I run this, what it's going to show me is what the person would have had to travel, how fast they would have had to travel in order for this to actually be legit. So for example, in the first row here, we have, we have Siraj logging in from, actually, let's use the second line here. We have Siraj logging in from Mexico and logging in from Brazil. Now, the times that he did it, and so those are physically about 8,000 kilometers apart from one another. The times that he did it, we don't really see the time specifically here. We'll see it formatted in the next section. But what we see here is he would have had to travel 27 billion kilometers an hour in order to log in from one place and another within the time period that he did so. And that's not legit. That's not possible. Somebody can't travel that fast. And so now we're starting to understand that this is not, it's not likely to occur. Now we want the system to confirm that. And so what we can do is we can say, you know what, anything above 500 or 500 kilometers per an hour or higher is suspicious. It's possible he boarded a jet plane and flew, but he wasn't going over 500 kilometers an hour. And so that's why we're saying here our suspicious speed, easy for me to say, is 500. Show us where he or she went faster or greater than 500. So now filtering out some of those results. And now we're starting to see when they logged in, how fast they would have had to travel and if it was possible. Now here is the ability to just format it all. What we're going to do with this last section is our data is not changing, but we're going to format it. We're going to take the IP address, the previous IP address. We're going to concatenate them. We're going to show just the countries. We're going to show the distance and the login times. And like I said, just really kind of clean it up. So here, that's what this field is doing, is saying, show us just specific fields we want. And so now it's a little more clear. Here, OnKit logged in from these two IP addresses that were in these two countries that are this far apart. He would have had to travel this fast in order for that to be physically possible. That's not possible. And so this is suspicious. Now, is he just using a VPN and testing from the United States and Indonesia? Very possible. Is he on vacation and has no access to a computer? This becomes a little more curious. Has he been fired recently? This becomes a little more curious. And that's what we're starting to show here. Now, once we have it done, and here's the whole final query. And like I said, it's a beast. But ultimately, same result. Go ahead, add it to a dashboard. I'm just going to call mine speed. And find that dashboard that I was using earlier, that's SOC 234. Click add. And now I have another new panel in there, or after I click add panel. All right, cool. All right, so let's see, on to lab 6. Actually, before we go to lab 6, quiz. So quiz question number 1, GeoLookup receives an IP address and returns location, true or false? So that's gonna be true. Yep, good job, true. The Haversine formula was used to convert octets to decimals, true or false? And that's false. The Haversine formula was used to calculate the spherical shape of the world. The octets to decimals was this, which you just won't use much, but yeah. And then land speed violations allow you to detect suspicious user activity, true or false. And that's true as well. All right, let's see. So that's lab 5, on to lab 6.
Hey, Josh.
Yeah.
There's a question that came up in the Q&A. Why do we want log entries with no IP using no drop? Won't we be able to as we won't be able to get geolocation calcs. Is there a particular reason in this query why we're using it? I know for others, but
No, for this one, let's see. Yeah, kind of just the way it was given to me.
yeah, I kind of thought that. I couldn't figure out why there would be one, but in general, I think this was just to introduce the concept of no drop in here, because there are times when you still want those log messages without the data in them because you need something else from another field in them.
Yeah,
that's why I wanted to answer this live instead of try to type up an answer.
Yeah, this was not the best example. I'm trying to think if I have a better one. I can't think of one off. I'm just kind of brain freezing.
There might be a good one under the no drop documentation.
Yeah, yep.
But yeah, that's hopefully that answered your question. If not, ping me back and I'll dig into it some more for you.
Cool. Thanks for bringing that up.
Thanks.
All right, so let's jump into, we were about to do lab 6. So with lab 6, what we're going to do is, it's called investigating using search parameters, which I guess is a perfectly adequate title for a lab. What we're going to do is use some more lookup tables. So we've already started to use lookup tables in a couple different ways. We used the geographic lookup table. We used that yesterday and today. So that we, looked up, as the quiz question just asked a moment ago, took the IP address and found the physical location. We used the lookup table earlier today of the shared event types. So in that example, we or I or somebody has created a lookup table, and that's the address for it, and you in the organization can reference it. What we want to do now is we want to create a lookup table, have you create your own to go through those steps of doing so and understanding how it works. It's really simple, which is good, but let's go through it either way. So what we're going to do is we're going to use the query in step 1. And as I've been doing, I'm going to copy it, paste it, and go line by line. So, and line by line. So the data we're about to create a lookup table out of or based on is based on actor, based on that user. So as we did earlier, as we were talking about earlier, if we want to have a pre-populated list of users or data, this is one way to do so. So the way I'm doing it is I'm pulling my data. I'm pulling CloudTrail data. I'm pulling the field for actor, as we've been doing a few times today. I'm going to run the first 2 lines just to make sure they work, and they do. And so now what I have is my message. I have my actor or my user. Now what I'm going to do is count, and I should do this for the last 24 hours. Doesn't really matter too much. Now what I want to do is I want to count by the actor, count by the user. When I do so, once again, doing count, doing aggregation, I get a new tab. And my tab now shows the user or the actor and the count. So how many times did this person log in? And it doesn't have to be necessarily a person. It could be a machine service or something, but we'll call it people for today. We'll give these accounts personalities, I guess. And we see they logged in. Now, for this exercise, I don't care about how many times they logged in. I would just want to see the actors, the users. I don't care if they logged in once or logged in 1,000,000 times. As long as they logged in once, that's important for them to show up on this list. So what I'm doing here is I'm saying, remove the count column. It's not relevant. Once again, if somebody logged in once or 100 times, as long as they logged in, that's what's being flagged here. So I'm going to remove that count column. And now what I have is just a list of actors, a list of users. Now I'm going to save that list to a lookup table. So I'm going to go ahead and save it to the location of shared. And I'm going to go ahead, like it says here, put my initials and put my number. So I'll do JB234. I'm going to just copy this just so I remember it. And now I'm going to go ahead and run this last line. When I run this last line, it's going to pop up a prompt saying, are you sure you want to run this? And then it's going to run it. Can I take the file? Oh, I think I've done that one before. Just put a little more flavor on it. There we go. So what I get back is my list again. But what we want to show now is now you should be able to find your list. So what you can do is you can now go to a new query. And you should now be able to run a cat command and say, show me that location. When I run it, I should now see my list. If and I'm going to go ahead and paste it in the chat, you want to take a look at my list, you can look at it as well. Since it's shared, anybody in the account can go ahead and access this. And so now I've created a list of users. Now the next step is taking that list of users and then making it available to look up as a parameter. And so we're going to do that. We did this similarly earlier with the shared event types, but this time we're going to do it for actor. So what we're going to do is we're going to go ahead and go into the lookup table. What are we doing here? Sorry. So we're going to go ahead and actually, we can do this just straight in the existing dashboard we have. What we can do is we can go to our dashboard. We can go to our filter. And we can then go to this gear icon right. Actually, no, wait. Where am I? I'm getting a little. It should have us save the parameters first. I guess we don't have to. Yeah, we don't have to. So going back to our search. So we need to go back to one of our dashboards. And then if we go into it, there we go. Now we can go to actor, 3 dots, manage parameter settings. And now we can identify that lookup file. So we're going to specify the lookup, and then we're going to specify the location, which is going to be that, in my case, this shared location. I'm going to select the I'm going to select the field for values. So I want to use the field of actor from that lookup table. And then I'm going to click save. Once I'm done, it should save it. And then if I go to my actor here and I remove the value of star, I should now get all those different actors or users that were part of that lookup table list. I can also choose to update this dashboard. Actually, I didn't really need to do that. But now I have those users. So just to go back here and make sure we're all together. So in our SOC dashboard, we want to open up one of the queries that we had already. We want to go to show and search. Once we were in that query, we want to go to the parameter itself, the actor parameter specifically. We want to reference the lookup location that we just created. And then we want to save it, which I didn't do yet. Yeah, and that's it. I feel like I missed a step here. No, but I think I got everything. Yeah. All right. And so what we were doing there was the idea of lookup tables. So you can create your own lookup tables. This is one way to do it. And I encourage you to do so. It's really a nice feature of Sumo is referencing those lookup tables, and they can be shared as mentioned as well. All right, let's see. So that concludes lab 6. For the quiz, let's see. So to display a lookup table, I use the command CP. That's false. I used cat. So good call there, Randy. Quiz number 2, true or false. Search parameters allow me to pivot quickly to any metadata values. Yeah, I'm going to go true there as well. And then 3, I use the save operator to create a lookup table. And that was true. So right there, that's save. Cool. All right, lab 7. Let me describe lab 7. So lab 7 is the idea of taking this dashboard that we just created and exporting it out to your production environment and actually utilizing it. Now, whether or not you want to do these steps, you don't have to. I'm going to run through them at a high level. But the idea is the fact that we created queries here. We created dashboards. We created views and information, data, or output of data, rather, excuse me. And we could utilize those in our production environments. What we need to do if we wanted to is follow the steps. Now we can export the dashboard out and export it in a JSON format. And so that's what these steps have us going through, is taking the dashboard, exporting it out, and getting the JSON. And then what you would do is very simply, well, sort of simply, is take that JSON data, put it into some sort of text editor, and all you would need to do is change the fields that need to be changed, specifically the source category, because your source category is probably not lab/AWS/CloudTrail. It might be production/AWS CloudTrail. It might be, it could be anything, but it's probably not labs AWS CloudTrail. And that's what we have you doing here, is the idea of taking that, exporting it out in JSON, importing it back into your production environment, and allowing it to run. So I don't know, I'm not going to go through each step. If you have any questions about it, please let me know, certainly. But wanted to show this as a nice little takeaway that you can leave with today. There are a few quiz questions, so I do want to go over those just in fairness. So export outputs JSON format. So didn't really go through that too thoroughly, but as you can see right here, it does. So you very simply just export. So once again, you would go to your dashboard and you would go to export, and here's your JSON. Question number 2, before importing, I must change the pointers to my data using a visual text editor. This is true. You don't have to use a visual text editor. I guess any text editor would be fine, but you do need to change those pointers so that you're pointing to your data, your source categories, not the ones that we're playing with. And then after importing, I cannot share the dashboards with others, so that's false. In the same way that you were able to share dashboards yesterday, we didn't really do it today, you could then take that dashboard that you imported to your production environment, and it would be sitting here, and then just like any other dashboard, you could share it with whomever you want. All right, so let's go into Lab 8. Lab 8 is a good place to end for a few reasons. Now, well, let's go through it. In Lab 8, what we're going to do is look at threat intelligence data. And this is, probably the best use of, not best use, but a use of security in our security use case here, a really good example of using an outside source of data to assist us. Now, we talked about outside sources of data already, specifically that NewStart data. Now, when I did my demo earlier, I did mention CrowdStrike data, and that's where this is going to come up to be relevant right now, is the data we're about to look up is CrowdStrike data. Now, NewStart data that I referenced earlier is mapping data, location data. CrowdStrike data is threat intelligence data. That's what they do. They do a great job of it. They charge a lot of money for their data, and we let you utilize it. And so what we're going to do now is start to utilize that data. And so we're going to take something, in this case, an IP address, but maybe something else, and start to look it up and see what does CrowdStrike think of it. Do they think this IP address is known to be malicious? Do they think it's not known to be malicious? We might treat those differently, and that's what we're going to get back here. So let's go ahead and start to jump in here. We have this example using a scheduled view, which is, it's a bit of a tangent, but it's relevant to the example, so we will use it. So what we're going to do is go ahead and grab the query that exists. So to grab the query, we're going to go into our scheduled views. And what a scheduled view is very simply a query that runs repetitively in the background. So this query is going to run in the background every minute and bring back results, essentially a minute delayed. But by doing so, we can call those results in a quicker manner than having to run the query on its own. So to get to the query, what we're going to do here is we're going to go to Manage Data. We're going to go to Logs. We're going to go to Scheduled Views. And the scheduled view that we want to look at, we have a bunch in here. Most of these are garbage, is specifically called IP_threats. So you should see this scheduled view in there. I'm going to go ahead and click on it. And when I click on it, what I'm being presented with is the query that's used to run the scheduled view. And so what I have is a query here. I'm going to grab that query and steal it, essentially. So once again, taking that, doing a new log search, and pasting the query in there. Now I'm going to run it. Actually, before I run it, I'll run it and talk about it. So what's happening when I run this? What we're doing is we're looking at data. Come on. We're not looking just specifically at CloudTrail data. We're not specifically looking at AWS data. We're saying look at all data. And that's what that star is representing. Bring back everything. Now, when you bring back everything, I want to parse out IP addresses. And what we're using here is regex, or regular expressions, to parse out the IP address. And so what the system is going to do is look for the format of number.number.number.number and recognize that as an IP address. So here, for example, it found an IP address. Here I found another one, so on and so forth. I'm then saying exclude those IP addresses that have 0.0.0.0 or 127.0.0.1. Because those IP addresses in this case are, we only want actual or external IP addresses. Those are private IP addresses, essentially. Now, here's where the magic happens, if you will. Here's the lookup line. Now, in the last example I showed you of a lookup with the geolocation data, we had a similar line, but different. Once again, we have a similar line, but different. So what we're going to do is look at this line and read it from right to left. So what is this line doing? What this line is doing is taking our IP address and comparing it to the threats that exist within the CrowdStrike database. So it's going to take IP address 129.174.188.35 and look for it in the CrowdStrike database. If it finds it, it's going to look up the type, the actor, raw, and threat level. And threat level, we're going to recall or rename and call it malicious confidence. And so these are just like we pulled back latitude and longitude. These are things that are relevant to threat intelligence. Mostly that's going to be relevant is the actor and this malicious confidence. So this malicious confidence is telling us that CrowdStrike thinks this IP is malicious. Now that's really helpful to know. What else do we see in here? Not a whole lot. The rest is kind of just parsing out the information and showing it into these fields. So what we have once everything runs is we have our count, we have our time slice, and what we're starting to see is during this 1 minute period from this IP address, there was a high malicious confidence. What we're also showing over here on the far right are the source categories of where the data reside. So, and this is why another reason why we're using a no drop. We were looking for all data, and now we're saying specifically, show us where that data was found. So this IP address, which is a high maliciousness, was found in our Tomcat data. This one was also found in our Tomcat data. This one was found in guard duty, and so on and so forth. Now, what I want to do next, and this is going to be in step 7, is start to detect outliers. I'm going to grab the query, paste it in, and talk through it. So I'm going to run this line here. And what I'm doing with this line is I'm specifying the fields I want. I guess I don't even really need to do that. Fields.
You deleted source on your paste. And again, go back again one more time.
Yes. Thank you. Yes. Yep. That's why we have helpers. Thank you. All right. So let me do this again. So with the fields, this row 2 here, I'm saying just show these specific fields. It's actually, I think, going to show pretty much the same fields I had already, but it's cleaning up a little bit. What I want to do now is I want to count by time slice. So I want to start to take these, and this will be a better view of it. And this is also, if you notice, there's a bit of a delay in returning the results. This is why this scheduled view is helpful. And I should be taking advantage of it. I'm really not right now. But what we're starting to see now is the system is counting essentially the, what would be the best way to describe it? The identification of maliciousness. I guess that's an okay way to describe it. And so what we want to start to figure out is, when are we seeing a higher or lower number of, or really an abnormality of things that are being identified. So for example, in this 1 minute period, it found 2,500 results. Is that a lot or a little? What we want to do is we want to have the system start to determine what's normal and what isn't. And that's what this fourth line is doing. And this is a really good way to finish up today, because this outlier feature is a really important feature in Sumo, in that it's going to let you, or really let the system, start to tell you what's normal and what isn't. So what the outlier is going to do is take a look at this count, and using math, and I'm going to refer to this as math just for a moment. I'll get into more detail in a moment, but for now, I'm just going to call it math, and start to calculate, like I said, what's normal and what isn't. So let's run this and see what it does. Taking a moment here. So what it's doing is it's starting to look at the actual value for that 1 minute period. How many messages did it find that matched our criteria? And what it's doing is it's starting to detect or create an upper and a lower limit using math to say this is normal. So what it's done is it said, okay, based on math, normal is between 13 or just about 1,400 to 4,200. The actual is 2,900. And so that's normal. That's within the range. That's acceptable. That's good. I'm going to modify my time period because I want to get some results that are a little bit out of range. These are a little too clean for me. And let me do this. And I'll explain what I'm doing in just a moment. I just want to get the results back first. 1 second here. Okay, so what it's doing is it's starting to calculate what occurred during a time period, what's considered normal, and it's going to let me know when things are abnormal. So for example, it's just about finished loading. Here, oh, it's still loading. But right here, for example. Oop. Come on. All right, so this line number 10 right here. What it's showing is the range the system was expecting, sorry, it's still loading, is between, let me just let it finish. Trying to get ahead of it, but. Okay, now it's done. There we go, sorry about that. So for example, this line 10. The system has determined that a normal value or an acceptable value is between 2266 and 3389. The actual is 3529, which is outside that range. And so what the system is doing is counting a violation here. It's letting me know this is outside the norm. Now, a better way to look at this is going to be through the line chart. Because what the line chart is now showing me is over the past 60 minutes, this blue line is representing the count of log messages that match our criteria. The pink triangle is representing the outlier, letting us know that at 2 points over the last 60 minutes, there were an unexpected amount of messages. In this case, we got more messages than were expected. And in this case, we got less messages than were expected. Now the math here is going to allow me to start to change this calculation. The calculation that's being used here is essentially standard deviation. I don't remember too much about standard deviation from high school. You might, or depends on when you learned it. It's essentially the bell curve and that idea of values balancing and averaging out. And so what we can do is we can start to change some of these values to change the math to change the reflection of what's being calculated. So for example, I'm going to change my threshold here from a 2 to a 1, meaning I'm going to change that standard deviation. Now what the system is going to show me, then it's going to take a moment or two to load. Actually, yeah, it's going to take a few moments here. And I probably should have stuck to a 15-minute period. Let me do that as well. But what's occurring when I modify this threshold is the system is now modifying the calculation it's using for that outlier. And it's going to change the results it brings back. And so it's doing it. Let's see, it's just about done. Okay, so when I changed my threshold from a 2 to a 1, I went from having two abnormal periods of time to having 5 of them. Now my data hasn't changed, just the calculation the system is using to determine what's normal and what isn't is being used here. And so that's what's taking place. I can modify my direction. For example, do I care that I'm having more and less messages than previously before? Maybe I only care when I have more messages than were expected. And so I can modify that direction to say only show me when things happen above the threshold. Something else I can change here, and it's just pulling a lot of data, that's why it's just taking a time to produce, is, and I want to show it, that's why I'm just kind of waiting here. Yeah, it's so much data. Let me use, actually, I'll keep it going here for just another moment or two. But what I wanted to show here is this consecutive, really all the math to go through each one. So with the math, we have the window. What the window is going to allow you to determine is how many periods, essentially, you're going back in time to start to calculate what is normal and what isn't. So with a window of 5, we're essentially going to go back 5 minutes and look at the data and start to figure out, like I said, kind of what's normal. The threshold is going to start to calculate that bell curve, that standard deviation. The consecutive is going to allow us, and let me see if I have an example here. I don't think I do. Yeah, I don't. Is going to allow us to decide, do we want to be alerted on every unique outlier, or do we want to wait for another outlier to occur immediately after that to prevent false positives? So what we can say is, instead of showing us the first outlier, wait until there's 2 in a row and show us the second one. Now, in this example, I don't have 2 in a row, so this wouldn't show anything. But if I do last 60 minutes, I will, but then I'm stuck waiting for it to return. So it's just going to take a little while. All right, so while that runs. So what I wanted to show in this lab, just to kind of bring it all home to some degree, is the idea of using CrowdStrike data. And that's really the most important aspect of this lab. Well, not the most, outlier is the second most, but the idea that you can use that CrowdStrike data to take your IP addresses or other things. It doesn't have to just be an IP address. That's most typical though, and start to look it up and have the system determine, is this bad? Is this good? Is this malicious? Is it not? Where is it being found? Where in your log messages is it being found? And then you would decide how to act on that. Maybe if you see a suspicious IP address, maybe you block it. Maybe you follow it. Maybe you blacklist it, which I guess would be blocking it. You know, you have some options there. All right, so that's going to conclude this lab. It got a little bumpy at the end. I apologize for that, but hopefully you got the feel for it. And then the outlier, just the importance there of allowing the system to determine what's normal for you. So highly encourage you to do it or utilize it. All right, let's go through these quiz questions kind of quickly. No, too quickly, but number 1, you check all incoming public IP addresses for possible malicious intent using our embedded CrowdStrike. That's true. The wording is kind of weird there, but the idea of it is that, yes, you can search public IP addresses through CrowdStrike. Question number 2, when using the outlier command, if you set the threshold to 3, that sets the standard deviation. So that's true. I alluded to that. I'm also going to just include, where is it? Just a link to the outlier article because it's much more thorough. I don't feel like I'm really giving it its due justice here. So just if you do want to take a look at that outlier article, it might be a little more helpful. And then we had the last quiz question, which was data. I didn't talk about this. So the question is, data doesn't count against ingestion when using pre-aggregated scheduled views. So we did not talk about that, but the answer is true. Let me see if I can find where it says it in here. It's mentioned in here. Now, let me show you the schedule view. Let me just do this because this is the way we should have shown it earlier. When I was running this query, I was running the actual query. What I should have done is run this view. And by running this view, it's now taking the data and giving it to me from the last 15 minutes. Now, why there's no data? This is the rabbit hole I was afraid to go down. So I don't think I want to go that deep on this right now. I was hoping it would just show up. Yeah, I'll look at that later. Yeah, I'll look at that later. It wasn't exactly showing what I was hoping it would. But that's one way we could use those scheduled views. All right. So that concludes the labs. Any questions, of course, please ask, but otherwise we're going to kind of move into the exam portion. Oh, good, Jeff, you are seeing data. Yeah, I think there's user error, me being the user error there. I feel like I have an extra space or not being patient enough, something. Yeah, no, I'm going down the wrong path. But good that you saw data. So what we want to do now is we want to move into the exam portion. So as we did yesterday, really kind of the same rules apply. And if you didn't take the exam with us yesterday, that's fine. We'll still go over the basis of it. But let's do that right now. So as a reminder, just my slides here. Here it is. So once again, we're going to take the exam. In this case, there's it says 20 plus questions. I think that's about right. You're going to have 60 minutes to take it. And once again, this is going to be an open resource exam. Open documentation is probably the recommended use, but open Google, open labs, whatever you want to use, because we want to continue to ingrain that idea of documentation, of how important it is and how useful it is as well. So go ahead and log into the system. As a reminder, it's going to be important that we don't take the exam as the training user, we take it as ourselves. So we're going to want to log out of the training user and log in with our personal or private or really professional Sumo accounts. So I'm going to go ahead and do that. Now, once I log in, I'm going to go same place I did yesterday. And so I'm going to go into certification and I'm going to select get certified. It's going to take a moment. And now I'm going to go ahead and select get certified. Now, the exam we did yesterday was fundamentals. The exam we're doing today is cloud security monitoring and analytic exam. So it should be the one where I'm trying to highlight on the far right, that exam. So you go ahead and click on it. And then same way as you experienced yesterday, it's going to ask you to register for free. As a reminder, there's no charge for you or your organization for these exams. You'll choose start. It's giving you the ground rules, in this case, 22 questions. You need a 70 to pass it. It's open book. You have 60 minutes, kind of all that stuff. Once again, you'll start the exam. You'll take it. Once you're done, you'll do better than I did. And then it's important that you click that submit button. As a reminder, without clicking it, you don't get credit for the exam, which kind of stinks. So certainly want to make sure you do that. Let's see, what else in here? That's about it. So once you're done with the exam, so let's just talk about the agenda for the rest of the day. So very quickly, here's where we are now. I think it's about yeah, so here's where we are now. So we're starting the exam at, I don't know what time local time is. I think it's about 11 o'clock right now there. So we'll take the exam, and then we've set aside an hour for lunch. So we'll actually get back together in about almost 2 hours from now. So between now and then, take the exam, grab some food. If you want to get some food for it, you can prioritize of that, of course. And then when we come back at 1 o'clock local time, we'll go over Cloud SIEM fundamentals. Now that is going to be a little more heavy on the slides. We do have labs, but just warning, it is a little slide heavy, but they're good slides. They're useful. So let's go ahead. Let's start the exam. Like I mentioned, I'm going to log off and probably grab some lunch, maybe or grab some dinner, maybe even take a little nap. Probably not, and then we'll come back together at 1 o'clock local time. So if there's questions, of course, Matt and James will be sticking around for a little bit now. And then we'll come back and pick up and continue. So thank you again for attending. Hopefully you found this helpful. I'm going to turn off the recording. All right, everybody, welcome back. Hopefully you're back from our session earlier. And we're going to pick up with a new set of content today. So in the past couple hours, we took that cloud security class. We did the certification. We just took our break, and now we're going to pick up with Cloud SIEM fundamentals. So let's go ahead and get started. I think we'll just get rolling here. As usual, questions, go ahead and post them into the chat. And yeah, away we go here. So Cloud SIEM fundamentals, first thing I want to do, like I've done with my other slides and presentations, is set the agenda. So here's the agenda. We'll stick pretty close to it. As you see here, we're going to alternate between content and labs. And I'll provide links for labs and passwords and things like that a little bit later. For right now, it's just going to be watching the video. Watching the slide rather, excuse me. So we're going to start with a review of Cloud SIEM data pipeline, what it is, how it fits into everything we're going to talk about for the next few hours. And then we're going to do some labs. Then we're going to go ahead and talk about threat investigation. Then we're going to do some labs. Then we're going to talk about customizing and tuning Cloud SIEM. And then we're going to do some labs. So you kind of see that theme going of content labs. And then, as previously, we'll take that exam. So another opportunity for you to get that Uber Eats. And so the more food for you, the better. So cool. So let's go ahead and dive in. So Cloud SIEM data pipeline. Come on, there we go. So what is Cloud SIEM? Certainly a good place to start. So Cloud SIEM is a cloud-based enterprise-grade security, information, and event management system. And that's where that SIEM, security, information, event management system. So that's that acronym, and we'll refer to it as SIEM forever. Won't really use the long version of it. So what Cloud SIEM does is it's going to leverage Sumo Logic's core functionality, which includes the data collection, the ingestion, storage, and threat intelligence. And some of that we've seen before. Data collection we talked about yesterday, threat intelligence we talked about earlier today. Now, Cloud SIEM is a purchased add-on with an ever-expanding library of content designed for security operations. Because it's designed for larger data volumes, most organizations need to ingest a large amount of data each day for insights to surface in Cloud SIEM. There we go. So what I have here is a map of Cloud SIEM. And so Cloud SIEM is a very powerful tool. It's going to take millions of log messages and funnel them down into a handful of actionable security insights. So how does that work? Essentially, at the very top of the screen, there we go, the logs are going to be collected and ingested by Sumo Logic into messages, very similar to the collection methods that we discussed yesterday. Then, once those messages are ingested, they're going to be parsed, mapped, and enriched into Cloud SIEM records. Now, we're going to talk about more details on that, but essentially the parsing is the taking of the data and looking for those fields and defining them and enriching it with Cloud SIEM data. We'll talk about that data shortly. Come on. Now once we have our Cloud SIEM records, the records are going to be compared to rules. If a rule is triggered, an entity is going to be extracted, a severity score is going to be assigned, and a signal will be created. Now, if we have enough signals with the same entity cluster together, they're going to become an insight. Now, we're going to focus on the later stages of this pipeline in this class. So essentially the bottom half of this, this data pipeline. The top half is something that we focus on in the Cloud SIEM administration class. So just FYI. All right. Now what I want to do is go into these a little bit more detail. So for example, we have a company, and in this example, and just very quickly for this example, we're going to use Sumo Logic Coffee. And so with Sumo Logic Coffee, the company is collecting and ingesting millions of log messages into Sumo Logic. Now, typically you can see these messages right away in many Sumo Logic apps. In order to use them in Cloud SIEM Enterprise, your admin must enable data forwarding. Your admin may also need to create log mappings and field extraction rules and other pre-processing steps to extract the right data. Once again, those are more administrative functions. Next, before Cloud SIEM can generate those security insights, the log messages need to go through that processing. And that processing with Cloud SIEM is going to take the messages and turn them into records. Each record is going to contain information from a message, which is going to be parsed into a key value pair, mapped to a Cloud SIEM schema, and enriched with other data. And this next screenshot or slide shows this a little bit better. So what I have here, come on, there we go, is we're going to follow a simple log message down this pipeline. So first, what we have is the message being parsed and extracted from the record. And that's what we're showing on the left-hand side of the screen here. So that parsing's occurring. And as described a few times, parsing is taking that data, creating fields and using those fields as values, essentially, or using the values from those fields. Now, what's going to occur here is once the message is parsed and extracted from the record, it's then going to be mapped into a set of key value pairs. One of the advantages of this key value pair mapping that occurs is it's going to fix some basic formatting. And in doing so, this step is going to create semi-structured data. So for example, on the left-hand side of the screen, we have our data coming in as IP-127-0-0-1. And the parsing step extracts the IP address into that key value pair. But what it does is it turns that source device IP, that new field, it takes that value and starts to normalize it by taking those hyphens and turning them into dots. And so now we have a more typical IP address. And so in this case, the information is mapped onto the Cloud SIEM schema. The information or the record can be enriched with information from match lists or threat intelligence databases, such as its threat level. And so here for this example, we've taken what the message that came through Sumo Logic on the left-hand side of the screen and formatted it to what we see on the right-hand side of the screen with that additional threat enrichment. And then these normalized records are then going to be sent down the Cloud SIEM pipeline and compared to rules. Now, this is where we're really going to pick up today in the portion that we're going to be playing with, or not playing with, but going through of the system. So what occurs here? So what happens is each record that's ingested into Cloud SIEM is going to be compared to hundreds of built-in and custom rules. If a rule triggers, an entity is going to be extracted and then a signal will be created. If a record matches the criteria specified in a rule, then Cloud SIEM is going to create a signal. And the severity is a number between 1 and 10 that tells Cloud SIEM how serious the potential threat is. When the signal is created, it's going to contain a name, an entity, a severity, a stage, and a description. A signal is always going to contain at minimum an entity and a severity. Now, I've mentioned that term entity a few times, and I haven't really defined it yet, and so now would probably be a good time to. The entity in a signal is going to be something like an IP address, a MAC address, a host name. The entity is going to tell us who or what was involved in the event that the record described. Entities are extracted from records, and every signal is going to have an entity. The entity's activity score is going to be the sum of all the severity scores of all the signals it appears in. Now we're going to talk about that math of the activity score with the sum of the severity scores a little bit later. So don't worry about it too much, but coming soon. So now that we have our signals, what happens? Cloud SIEM is going to take everything one step further and correlate these signals into a manageable number of insights. Now, an insight is going to be a group of signals that's clustered around a single entity. An insight is going to be created when the sum of the severity scores of the signals with the same entity goes above a certain activity score within a certain time frame. Once again, starting to get a little mathy, but I'm still going to mention this, but we'll look at a better explanation of this a little bit later. Now, with the math and the scores, by default, an activity score of 12 within the last 14 days is what is going to trigger an insight. Once the insight is created, then you can start a security investigation, take actions like alerting SOC teammates or executing playbooks. And we're going to take a look at that as an example very soon. another 2 minutes or so. Now, before we do log in, I want to just show the data pipeline here. And what I'm showing here is, and you're going to see this in a moment in app, but what we're showing here is the entire data pipeline, and it can be thought of as a funnel with our log messages going in the top and the insights coming out the bottom. And so while you might ingest millions of log messages, you will only get a few hundred signals and possibly a handful of insights. And what we're showing here is what's called the insight radar. And you're going to see this, like I said, in the app in just a few moments. But what it uses is a funnel shape from a top-down perspective. As you go towards the center, there's going to be fewer items. And so what I'm not trying to represent, what is being represented here in the outer ring, which is representing the outer ring in the dark blue, is representing the records that have been ingested. And so what we see here is relative number of records in the last 24 hours. And so we can start to see dips and spikes, which represents time where there were more or less records ingested than average. We have the middle circle here, which is represented essentially by these light blue bars. And the signals here are representing exactly that, the signals that are showing up from the records. Same idea, the higher the bar is, rather, the higher amount of signals are being created at that moment or during that time period. And then in the innermost circle, we have our insights that have been correlated from those signals in that blue bar ring. So here we have triangles that are going to represent insights. And we'll take a look at these, in, like I said, in more detail in just a moment, but just wanted to give you an overview of what we're about to look at. So what we're about to do now is start to log into the system. So you probably kind of know where I'm going with this already. So we're going to go ahead and log in. We're going to use those credentials that we've been using previously. If you haven't logged in with us before, choose a 3-digit number for the number portion of that Training Plus Analyst email address. If you've used numbers with us before, go ahead and use the same numbers. If you want to use a different set of numbers, that's fine too. It really doesn't matter at all. And the other thing I want to provide to you, let's see if I downloaded it, is the labs. So just give me a moment here. Let me just download them real fast. Sorry, I thought I did this earlier. Actually, I think I did do this earlier. I just don't know where I put them. All right, so let me go ahead and post this into the chat. What it is a lab guide. So previously, when we were accessing the labs, we were accessing them through a web interface. Here we have them in a PDF. So let me go ahead and just post those in there. Okay, it's uploading now, so you should be able to grab that PDF. And so ideally, you will have a PDF and you'll be logged in. And let me go ahead and log in just so we're all on the same page here. If you need help with either portion, just let us know. All right, so let me just kind of catch up with you. So I have Sumo open. I have, where did I just put my lab guide? I have my lab guide over here. And now let's go ahead and take a look at it. So we're going to go ahead and do, actually, close this. Okay. So we're going to go ahead and start with lab 0. And lab 0 is essentially just logging in. So ideally we have all logged in. Once again, if you need help, let us know. Now with lab 0, what we also want to do is log in and actually go into Cloud SIEM Enterprise. So previously we've been logged into Sumo, so the Sumo interface should not really be new to you. But what is new, or at least we want to call attention to, is on the left-hand side of the screen, the black bar, we want to look for Cloud SIEM Enterprise. Clicking it should open up exactly what I see here. And that's all with lab 0. So just to confirm, we should all be logged in. We should have our lab guides, and now we should be in the Cloud SIEM Enterprise view, looking virtually identical to this. All right, cool. So what we want to do now is a couple things. As it mentions in the lab guide, if we click on the Sumo icon up here, it will bring us back to this screen. So just as an FYI. That's about it in lab 0. But let's jump into lab 1. So lab 1 is having us utilize this page. And so I started to talk about this page, or at least this insight radar earlier, but let's look at what's going on here because there's even more information. What we see on the top left is a summary. And the summary is sort of powerful in what it's expressing to us. By default, we're looking at a last 24-hour period. We can adjust that, and we will adjust it playing with the labs in a few moments. But what it's showing us is how many records it looked at, how many signals it produced from those records, and of those signals, how many insights it wants us to focus on. And so what we're seeing here is the kind of the scale of the benefit that's being provided. The system over the last 24 hours has looked at 15,000 records. So 15,000 records have come in, systems looked at them. Of those 15,000 records, it created or generated 6,000 signals. That's a lot of signals. But of those 6,000 signals, it's only pointed out 4 insights, 4 things that it really wants us to look at. And so there's a lot of power in taking 15,000 and distilling it down to 4. And explicitly telling you what 4 to look at, represented by these triangles. And we'll look at these in a few moments. And so that's, kind of cool. And so what we're going to do in lab 1A, B, and C is just play around with the time filter and just see, how helpful the system is. So for example, in 1A, how many records have been ingested in the last 8 hours? So use our little time, switch it to 8 hours. And now we see 5,000 records, 2,000 signals, and only 1 insight. So in the last 8 hours, we could have looked through 5,000 records manually to maybe see something. Instead, the systems let us know, hey, there's 1 thing to look at. Go check it out. And we'll go through, like I think I just said, how to check it out in a few moments. Next one, how many signals have been created in the last 7 days? Same idea, go to this, 7 days. And, from the scale, it's probably the best example of, 250,000 records have been ingested, and there's really just 24 things to look at. That's pretty manageable over 7 days. And then how many insights have been created in the last 24 hours? So pretty straightforward. We also see the insights by status. We'll talk about adjusting these statuses, but what we'll be able to do is grab one of these insights, and feel free to poke around. I know we're going by the lab book, but if you want to start clicking, feel free to. I'm not going to really know, and that's okay. So what we're seeing here are these insights by status, and we can start to see how many are new, how many are in progress, and we'll see how to claim them and mark them as closed a little bit later. Now, in the center of the screen, this was the insight radar that I described. And this is, I think it's cool looking. And I guess I should justify the use of the word cool here, but it's meant to evoke some emotion, and the emotion it might, or not emotion it might bring out, but is making you think kind of a video game look and feel. And this was very intentional. The individual that designed this has designed, done work for World of Warcraft, which was a more popular video game many years ago and still is. And so it has, it's meant to, at a glance, heads up display, do what it does, show you what's going on in a very simplistic but powerful way. And so that's what we're seeing here. So as described, around the ring in the blue, we start to see the records. So if we're looking at the last 24 hours, we can start to see when the most amount of records were ingested, which would be the peak here. And we can see kind of the valley when the least amount of records were ingested. Now, similarly, if we want to look at the signals, kind of the same idea, except we're using the bars as the scheme of identification. And so the higher bars would indicate more signals were created. A lower bar would mean less. Now, this is lab data, it replicates, and so that's why these bars are all fairly consistent. As you see, it also refreshes itself every 30 seconds. I guess we can time it periodically. And then finally, the insights are represented by the triangles. Now, the insights, although we do have 4 here, a triangle could represent more than one insight. So if there were 2 insights that occurred from 8:30 to 9 o'clock here, we would have 1 triangle, but when we mouse over it, there would be 2 insights. So the triangles don't always match 1-to-1. They can represent more than 1 insight. So just kind of an FYI. All right. That's all for that lab, or that portion of the lab. What we want to do now is we want to go into step 3 of lab 1, which is starting to look at the rules. So as described, there's hundreds of pre-built rules within the Cloud SIEM environment, and we want to look at those right now and show them to you. So to access them, what we're going to do is go to the very top of the screen and go to Content, and then go to Rules. By default, it should not have a filter in place. And what we should see are the rules that are in the system. And by default, the majority of these, there's some in here that are a few test ones, but outside of these kind of first 4 or so, these are all going to be rules that we at Sumo Logic have created. And we're going to talk about how to utilize those shortly, but want to show you the rules in the first place. We can utilize our filters to start to look for specific rules. So for example, how many rules have the name of firewall in them? So we can do our filtering, and we can use contains phrase starting with firewall. And so now we see there's 11 rules around firewalls. We can continue to use our filtering. I'm going to remove this filter and create a new one of how many rules have a severity score greater than 8. And remember, those severity scores are going to be helpful to understand how severe the issue is. For example, if we wanted to look at looking at those scores, one of those scores or one of those fields is filterable. So under severity, greater than 8. And so now we see the severity scores of 9 or 10. How many rules let me remove this one. How many rules detect the persistence tactic? We'll talk about tactics and techniques pretty soon. But what we have the ability is to start to look at these tags that have various tactics and techniques. These are going to be related to the MITRE attack framework. And like I said, we'll just talk about that in a few minutes. But so we could go ahead and look for the tactic called persistence. So just showing you how to filter. It's a little bit different than other filtering methods that we've used before. And so just wanted to kind of have you get used to it a little bit. Now, what I want to show next is the entities. So what we can do is we can go to the top nav bar, and select entities. And remember, these entities are like, I refer to them as nouns, which I don't know is really the best way to refer, or proper nouns, but essentially they're going to be the who or the what's, the usernames, the IP addresses, the host names. Those are really the most common ones. And so what we see here are 103 entities that the system has found and recognized as being the who or the what's. Once again, we can start to filter these in a similar manner. If we wanted to look at the entities and figure out which have an activity score of 5 or greater, and so we're filtering. How many have an activity score of 0? And so on and so forth. Now, there's a discussion. I guess we can, I don't know that we'll have a true discussion about it, but what does an entity with an activity of 0 mean? Does anybody know? No recent data and insights. Sure, that's one reason. Yeah, absolutely. And so the system basically has found something, but not attributed it to anything else. So yeah, the no recent data and insights are a pretty good answer for that. All right. And now what we can do here is just to wrap up this lab, we can click on the HUD icon on the top left, and it will bring us back into that heads-up display. All right, so what I'm going to do is I'm going to go back into my slides. I hope you'll follow me into the slides, but if you want to, like I said earlier, kind of poke around in here, feel free to. I can't stop you. So let's go back to some slides. And so what we just went through is, come on, slides. There we go. So we looked at the UI, essentially just understanding the basics of the summary stats, the insight radar, the built-in rules, and those entities that were being tracked. Okay. All right, so what we want to do now is continue. And what we have is the ability to utilize a couple different use cases for today. And so what we have here are, we have 3 fictional companies. We have Financial Logic, Sumo Pharma, and Sumo Coffee. And so each one has their own concerns as in their own market space and can benefit from Cloud SIEM. So here's a couple of the use cases that we can discuss, or I am discussing right now, but we'll go into more detail shortly. So we have Financial Logic. They're a major player in the banking industry. Currently, they meet all the GDPR and other international compliance standards, but their big worry is that their big investors are going to be targets for hackers. Now, Sumo Pharma is a healthcare company that ships prescription meds to patients. Now, of course, they're going to be worried about hackers and all that, but their main concern is, even though they meet all HIPAA standards and guidelines, they're concerned about data privacy. So they want to monitor all their data to make sure their patients are safe and healthy in the digital world. We have Sumo Coffee, which is a small retail business with a big tech idea, automating the entire coffee business from bean to cup. Now, in addition to consumer protections like PCI DSS, their main concern is keeping computing costs down while their startup grows. And so they all have their own concerns. Now, what I want to talk about next is threat investigation and threat hunting and how the two kind of tie together. Threat investigation is reactive, while threat hunting is proactive. Now, typically, threat investigation happens in response to an alert. Once you've investigated a threat, you can hunt for similar threats and take precautionary steps to prevent attacks from happening again. Threat investigation is an iterative scientific process, much like troubleshooting. In both threat investigation and troubleshooting, you're first going to monitor your system. Once an anomaly is detected, you can make a hypothesis about how it happened and diagnose the problem. As you dig deeper, you may revise this initial, let me take that again. As you dig deeper, you may revise this initial hypothesis and find more clues about why or how the attack or error happened. And as you investigate and trace these events, you want to start to answer as many WH questions as you can about the event to tell the story, excuse me. So you want to start to ask yourself, who is behind the event? What assets did the event affect? Where did the event occur? When did the event occur? Why did the event occur? And finally, how did the event occur? Once you've done that, you can finally take some action to resolve the issue. And there's going to be many actions you can take in response to an incident. For example, you might need to work with your IT team to isolate and wipe laptops that got infected with malware and prevent them from spreading malicious code. You might need to work with an HR team to enforce mandatory anti-phishing training among employees to prevent future attacks. Many ways to kind of take this and go with it, but you have that ability, and we'll look at that in more detail shortly. Now, what I wanted to present here is, as it says on top, a day in the life of a SOC analyst with Cloud SIEM. Cloud SIEM is going to be able to help with every step of the threat investigation process. And so let's take a look at that. Cloud SIEM is going to automatically detect and monitor potential threats by analyzing millions of records and distilling them into a handful of insights with a low false positive rate. You can choose those insights from the homepage of the Cloud SIEM, as we started to talk about earlier. So many ways to get to the insight themselves, but you have that ability. Now, once you choose an insight, you can start to dig through all the raw logs and signals to conduct deep dive investigations and even proactive threat hunts. You can organize your thoughts, make hypotheses, and take notes about your investigation in the comments of each insight. And this is going to be helpful to share your ideas with your SOC teammates and help you keep track of your investigation. You can also take certain actions directly from the insight. You can email teammates, you can create JIRA tickets, execute playbooks, and many other custom actions with the Actions button. And then finally, you can update the insight. You can mark it as in progress or closed. When you close it, you can mark it as resolved or a false positive or duplicate or no action. And updating the status correctly is going to help Cloud SIEM's insight engine produce more accurate insights for your org in the future. Now, of course, the process will repeat each day as new insights are generated for you to investigate. Now, the next thing I want to talk about is MITRE ATT&CK. I mentioned this earlier. I didn't really go into detail on it. If you're aware of this, it's cool. If you're not, that's okay too, but let me explain what this is. What I'm talking about here is what's called the MITRE ATT&CK matrix, and it's published by a group called MITRE, and they're a nonprofit research organization. And if you notice, the word attack is spelled creatively. What attack stands for, in this situation at least, is adversarial tactics, techniques, and common knowledge. And what this framework does is it essentially organizes and categorizes the tactics and techniques that criminals, hacktivists, nation states, scripters, and other adversaries might use. And this is going to include things like attacks like exfiltrating databases, installing malware, stealing credentials, and all these other nefarious activities that you and the SOC team are trying to stop. And so Cloud SIEM uses these same tactic names for the stages of signals and the names of insights. Not required, once again, that you know the MITRE ATT&CK framework, but if you do, it can make navigating Cloud SIEM's insight pages a little bit easier. I'm going to go ahead and paste in the chat a link to the MITRE homepage, just in case you're curious. Once again, it's not, I don't think anything we test you on, but just more information. Now, in relation to this MITRE ATT&CK framework and our use cases that I was talking about earlier, let's talk about these fictional companies and which MITRE ATT&CK tactics and techniques, hard to say, they might prioritize. So for example, Financial Logic, they needed to keep their clients' data secure. So for them, credential access is a concern. All their customers have user credentials tied to their financial accounts. And so making sure credential access is being done responsibly is important. Sumo Pharma, Now, of course, they're worried about credential access, but their priority of concern is around that patient's data privacy, compliance with HIPAA, things like that. So exfiltration of private data for them is a major concern. Sumo Coffee, that group that's really more worried about resource management, that's really their concern. Execution, which is one of the MITRE ATT&CK use cases, is a particular concern because executable files can utilize precious computing resources, and that's not what they want to allow. So they can all focus on different use cases, and we're going to use these use cases in just a few moments to go back in the system and look at how they work. But I do have a few more slides, so let's go to them. So the insight page, which we haven't shown yet, is going to start to show you everything you need to know about unraveling the security event. As a reminder, when the signals cluster together, Cloud SIEM is going to use tactics and techniques naming scheme to name the insights that they generate. The insight's name is going to point you to how the event occurred or why the adversary is behaving that way. For example, a tactic name like discovery or persistence might show the reason the adversary has. A tactic name like initial access or execution might also tell us about the methods the adversary uses. These names are just starting points, and you may need to revise your hypothesis as you continue your investigation. So a very simple example, we have an insight here called credential access. Why did the event occur? Well, probably so the adversary could use your credentials. How did the event occur? Probably by accessing your data. Very, very simple. Now, what we're also going to see when we get into the insight is a timeline, and the timeline is going to be very helpful because the timeline is going to tell us when the event occurred. And so what we can start to see here, and it's very blue, so hopefully you can distinguish the different shapes, and the shapes are really the variation there. But what we start to see here are when signals were triggered. Were they triggered at the same time or sequentially? Or did everything happen over a period of minutes, hours, or days? Now, by default, remember the insights are related to signals that cluster together for the last 14 days. So let me just repeat that. The insights are going to be related to signals that cluster together within the last 14 days. So what we're showing in this example is we see some signals occurred several days before the others, which we see on the kind of far left and the middle portion of the screen here. But what we see on the far right is 3 of these clustered more closely together more recently. And that's helpful to start to see that from a visual standpoint. Now, the other thing that we're going to see within the signal is that entity. And once again, that entity, it might be repetitive, but that's that who, the what, the where the event occurred. That entity might point to the IP address of a hacked device. It might show the location of an adversary, the location of a database, the owner of a website, or some other piece of the puzzle. And each insight is only going to have one entity each insight is only going to have one entity it's clustered around. All right, so what we want to do now is jump back into our lab guide. And so let's go back into our lab guide. So here's my lab guide. Now, what we have in our lab guide is we're going to go to lab 2. In lab 2, we have 3 different use cases that we just discussed. We have financial logic, we have Sumo Pharma, and Sumo Coffee. And what we're going to do is we're essentially going to pick one example to do right now. The other examples you can do on your own. You can do them at a break. They're going to be pretty similar, but you can do them. So let me go ahead and paste that PDF back in. Cool. So the first one we'll just go in order. We'll just do the financial logic one just because it's first. So what we're going to do is we're now about to look at an insight under the vein that we are part of financial logic. So let's go ahead and look for the insight that we need. So what we're going to do is we're going to go back into Sumo Logic. Hopefully we're still in Cloud SIEM Enterprise. And we're going to go into our insights. So at the very top of the screen, click on the insights. When it loads, or as it loads, it's going to now show the insights. What we see now are many insights, 1,000 of them. And what we want to do now is pick a specific one. The one we want to pick is specifically one that says persistence with initial access. Now, there's going to be many of them. These replicate. So you can go ahead and either kind of scroll around and find one, or you can go ahead and use the search capabilities. Scrolling around and finding one's probably easier, but if you want to, you can also search for it. So I'll grab one that's a little further down. I'll grab this one. Now, when I click on it, I'm now being brought into that insight. And so what do we see here? Well, we see everything I've been describing. Now we're starting to put it all together. So in the center of the screen, many places to start. Let's start on the left-hand side of the screen, sorry. So on the left-hand side of the screen, we start to see the insight name. We see the MITRE attack a technique that's been applied here. We see the status. So if this is new, if it was not new, that's going to be helpful. We see if it's assigned to somebody or not. In the real world, you'd want to assign these to yourself or somebody else, and that's an important feature. We see the entity. So here is kind of the, not the key, but the who or the what. Remember, that entity is associated with the insight. And then what we see some other stuff in here, but nothing really too exciting. But what we see in the middle here is the timeline, and then we actually see those components that make up the timeline. So for example, in the timeline, what has occurred is we see some threat intelligence has occurred, and we see some rules have been triggered. And if we scroll down below, we see the specific details. So what we're seeing in this first one is, well, exactly what was triggered: threat intelligence. The device IP matched the threat intel file hash. And so we're starting to see something that was observed as being curious. And we see other things going on here. I'm being a little vague when I say things because I want to tie it together, but just for right now, I'm going to call it or refer to it as things. So we also see other activities that have taken place with this insight. So now let's start to kind of put this together and figure out what has occurred here. What is the story that's being shown here? So what we see are a threat intel, a file hash has matched something that's known to be malicious. We see a user received an email with a phishing link. We see Checkpoint has detected some maliciousness of this file. And we see some more CrowdStrike detection as well. So we see a lot of different systems being triggered here: CrowdStrike, Checkpoint, Proofpoint, and then threat intel. Now, what happened? So let's kind of go through this narrative. So what we see here, and this is going to be in the summary, I'm kind of reading along, but we're going to see what it says, is what we have is our phishing link was received. A few minutes later, a malicious file name was allowed, a malicious file was allowed, excuse me. So the email was received, somebody clicked on a malicious file. And so that link was downloaded. The file was downloaded. Threat intelligence came in and recognized that the zip file, where is it? It's right here. The zip file has a known malicious file hash. And so as a result, these signals fired and the insight was created. And so what it seems like occurred is the file was downloaded, was known to be malicious. And so how should financial logic prevent this from happening? Well, they could lock the user's account. It says they could re-image. They could train the user not to download files. They could have the files downloaded to a safe environment. You know, a couple different ways of how to approach this, but this is what the system is telling us. And we were able to understand that and go through that all by looking at the insight. So let's grab another one. Let's see, time-wise. Yeah, we could take a look at another one. Let's look at let's look at 2B real fast. So we'll just go through what it's showing us. So with 2B is Sumo Pharma. What we want to do is we want to look for the insight that has it exfiltration. I'm just going to see if I can find it. I probably can't. So let me go ahead and try and search for it real fast. Tags, contain, tactic, exfiltration. Actually, that's not exactly what I wanted. I wanted exfiltration with credential access. Let me see if I can find it real fast. No, it's not a technique. No. Let's see. Should be. Yeah, here it is. No, that's command and control. Let me just see if I can find it. That's why I don't usually use that example. Yeah, I can't find one. Control, not control. That's weird. Here's one. So similarly, we can take a look at this one. And we kind of get the same idea, not the same idea, but we see another story, another narrative. So in this case, we see guard duty has been triggered, more guard duty around some instance exfiltration. We see guard duty is finding this user of IM user Kali Linux pen testing occurring and some unusual traffic. And so we can start to create or develop a hypothesis of what happened here. So we can decide what we think happened, and what we're seeing here as described in the summary is unauthorized access in the form of credential exfiltration was detected. Then about an hour later, guard duty detected penetration testing from a user named Kali Linux. Several hours later, we see the high traffic volume, and that's being detected as well. And so what we could come up with our hypothesis, but what actually happened here is, in this case, Sumo Pharma was being proactive in finding vulnerabilities, and they had created or utilized a consulting team to do some penetration testing. So what we had done is we could kind of advance this up the chain and figure out, who is this user? Is this user appropriately using penetration testing and doing penetration testing? If they're not, then this could become a little more suspect. And so that's what we're being told here, essentially. All right, let's go back to my slide deck here. Oop. And here we go. Actually, let me see where we are. Maybe we should take a break in a few minutes. Yeah, actually, we're good. We'll go another few slides and then we'll take a break. All right, so the next thing I want to talk about here is, as it says, a deeper dive into threat investigation and threat hunting. Talking about the insights, but monitoring signals and entities as well. So the insights, as hopefully just described, provide a great high-level summary of potential security events. And because of Cloud SIEM's threat intelligence and sophisticated correlation, very few insights or false positives occur, so they're all worth investigating. However, sometimes you want to dig or investigate deeper to really understand what happened. Sometimes you want to be proactive and do some proactive threat hunting work to find potential problems before they begin to impact your system, even if some of what you're looking at are false alarms. The Signals tab is going to show the list of all the signals created by the rules that have been triggered in your system in the last 14 days. And those signals are going to provide summaries of potential security threats, but not all signals are security instances. Now, when you click a signal, you have the option to see the full record or the full detail of the record that triggered it. And this is going to include information like the IP address, geolocation, threat level, and other information. The Entities tab is going to show all those rules that have entities that have been detected in the last 14 days. Each entity has an activity score associated with it. And we looked at that a little bit earlier, and actually you see that on the screen right now. Once again, when an entity's activity score reaches 12 or higher, then an insight is created. You could have several entities that have relatively high activity scores, and if you do, that's a good starting point for a threat hunt. Next thing I wanted to talk about is the context action, and you see an actual image of it right now. Context actions are going to be found throughout the Cloud SIEM UI, and are going to be helpful for the in-depth investigation. Many entities in the insights, the signals, and entities pages will have context actions. hover next to the certain entities and the 6-dot icon may appear. And that's what I'm showing. I'm showing the whole thing right now, but I think we'll see an example of it in just a moment. There we go. There we see the 6 dots, and then we see some of those context actions that are available to us. The context actions might be something like inserting the entity into an API call, doing a DNS lookup, and other tasks. And administrators can add those custom actions as well. Now, an in-depth threat investigation is going to use the most use both Cloud SIEM and Sumo Logic's core tools. So we can use these together. There's going to be several ways to bring the information you find in Cloud SIEM back to the Sumo Logic platform. One context action that you're seeing right now is the Sumo Logic search. And so what you can do is select this action, and it will create a log search in Sumo Logic. And this will allow you to find all the log messages with that entity, even if it wasn't detected by a rule in Cloud SIEM. And we're going to just try that out in just a few moments. And so this is exactly what we're going to do in a few moments, but essentially we go to the entity, we go to the 6 dots, we have our list of actions. In this case, we're going to select Sumo Logic search. And what it's going to do is very, very simply take that IP address and bring it into Sumo Logic. All right, finally, before we get back into our labs, is finishing the investigation. So in Cloud SIEM, there's going to be several actions you can take on each insight. You might want to comment on the insight. You might want to close or assign a status like we're going to do in a few moments. When you close an insight, Cloud SIEM is going to use that resolution information to reduce false positives and duplicates even further. So highly recommend doing so, keeping that information in there. You can also assign the insight to yourself or a colleague. And once again, you can use those action buttons to alert colleagues, also create JIRA tickets, send Slack message, and other APIs. And those action buttons, admin configurable. So we don't cover setting those up today, but certainly if that's interesting to you, the admin class is there. All right. Let's go ahead and jump into lab. Come on. Lab 3. So what we're going to do is go back into lab 3. So I got I got too many windows going on. So let me close the slide deck. Let me open Sumo. Let me go into my lab guide and let me utilize, here we go. Let's utilize lab 3A. Sorry. So here we're going to use lab 3A. And so what we're going to do is do a bit of a continuation of the financial logic demo or example. And so we're going to use that persistence with initial access that we used earlier. So once again, I'm going to go back to my insights. I'm going to look for that persistence with initial access. I'll grab this one, doesn't really matter. And what I want to do is show, first I want to show the entity doing the Sumo Logic search. So what I'm going to do is I'm going to go to the entity. When I go to the entity, which is in this case the IP address, I should have these 6 dots appear. I can then click on those 6 dots, and now I have a whole variety of different options. I could take this IP address and do a Google web search, add it to a match list, look at it through VirusTotal. But in this case, I want to do a Sumo Logic search for it. And so when I do that Sumo Logic search, it's it is taking that IP address, copying it essentially as a keyword, and then pasting it in. There's my live code. All right, so we've taken this IP address and we're now going to start to look for it in Sumo Logic. Now, by default, it's not showing up anything, but I think I just need to do a larger time frame. There we go. Cool. So now I'm getting data. And so what I'm being shown is where this IP is showing up in my Sumo logic instance. Now, what we're going to do here is we're going to create a query that's going to take this data and slice it up a little bit cleaner for us and start to show us specifically where this IP address is showing up. Now, I can see here, only because there's not many records, that the data is showing up in CrowdStrike. It's showing up here in these signals. This IP address is showing up in other signals, in my network Zeek information. But what I want to do here is I want to create essentially some aggregation to display that information rather than just showing a list. And so what I'm going to do is I'm going to use the query that's provided in here. I'm going to paste it in. I'm going to grab that IP address. I'm kind of doing this backwards, but it's okay. And so what am I doing here? What I'm doing is I'm saying, or what the system is doing, I guess I'm not really doing much here, but what the system is doing, and let me grab that transposing, because that's going to be important. But let's go line by line. Oop, come on. All right, there we go. So line by line, what are we doing? First, we're looking at, as it says here, the security record. So this, or it's not the security record, but it's the SCC record, which is referring to all the records that have been ingested in Cloud SIEM. Then we're going to go ahead and do our time slice so that we can take our data and break it up granularly in those time periods. We're going to look just for the IP address of this IP because that's all we care about. And what we're going to do is we're going to count the results, and I'll do this transposing last, by vendor and by product. And what this is going to help us understand is where this IP address is showing up. So this IP address is showing up related to Proofpoint and related to CrowdStrike. And that might mean something to us. If it was showing up in our Apache data, that might mean something else. Maybe we want to start to see where that user's coming from, where they're going, what they're doing. And so that's what that's doing here. I can do the transposing. There's really not much data, so the transposing doesn't really make it that much prettier. But it helps a little bit. And so what I now see is during this 1 hour time period, this IP was detected in Proofpoint and CrowdStrike. All right. Now, once we're done with this, what we can do is we can go back into our Insight and we can wrap things up in here. So what we can do is we can go ahead and go to our actions, go ahead and select, well, we could use any of them. We can set the status. So we can use our actions. We can set our status. We can assign it to somebody. And then what we can do is ultimately choose to close the insight. When we close the insight, this is going to be important that you use the best example or best situation here, because the system's going to start to learn off this. So what you want to do here is go ahead and select, in this case, of course, it doesn't matter, but in the real world, we want to choose the thing that was most appropriate. So if this is a duplicate or a false positive, we want to be explicit here in defining that or labeling it so that the system can start to learn in the future. All right. Let's go ahead and I think we're about ready for a break. Let me just make sure on our slide deck. Yeah, we're ready for a break now. So let's do we'll do another 8-minute timer here. So we'll go ahead and we'll take our break. When we come back, we'll do a few more slides, a few more labs, labs, and then we'll take the exam and kind of wrap things up. So thank you, everybody. I'm going to go grab a little beverage and hope you do the same, and we'll come back shortly and continue. All right, everybody, welcome back. Hopefully you had a good little break. Let's go ahead and continue. So let's go ahead and jump in. I'm going to do a few more slides. Going to have about 10 more slides, and then we'll do some labs. All right. So, yep, you should be able to see my screen. Okay, I think we're good to go. So what I want to do is talk about Cloud SIEM rules. Now, once you've completed a few investigations, you may want to add or modify rules, data sources, match lists, and other pieces of the Cloud SIEM puzzle. And these modifications can help reduce false positives or alert you even faster. And the most common things you want to customize are going to be rules or insights. Rules are one of the most important pieces of the Cloud SIEM threat detection engine. All the records that are ingested in Cloud SIEM are going to be compared to every rule in Cloud SIEM. Remember, records are just normalized log messages. Now, if there's a match, an entity is extracted and a signal is created. Those entities are tracked and may correlate with other signals to create an insight, which is where most threat investigations begin and where we're playing around. Come on. There we go. Now, next I want to talk about custom file types, or custom rule types, excuse me. Now, you don't have to write these rules from scratch. As mentioned, Sumo Logic, the team has created hundreds of out-of-the-box rules to get you started. And we saw an example of that of when we just went to rules and we saw, what, about 700 rules. Those were ones that were created by Sumo Logic. We create new rules every day. They get updated frequently. But sometimes you might need to write a rule from scratch. Now, why would you write a rule from scratch? You might want to do this if your system has a source that isn't covered by the default rules, or if you're looking for a threat that isn't covered by the default rules. Custom rules are not going to be updated or deleted by Sumo Logic during the regular updates. They're independent from default rules. If you do decide to create custom rules or rule tuning expressions, those rules will once again not be modified or deleted by Sumo's regular updates. Now, there's 4 different types of rules. The first one is a match rule. A match rule is going to take a very simple Boolean statement and check if it's true or false. If it's true, then an entity will be extracted and a signal will be created. So for example, we might want to look at whether an IP address matches that of one that's on a banned list. True or false, very kind of binary in that way. Another type of rule is called threshold rules. A threshold rule is going to be triggered when a match is found a certain number of times. So for example, if 1 failed login attempt is okay, but 5 are not, then a threshold rule could fire after the 5th failed login attempt. Another type of rule is chain rules. These are going to occur when certain different events happen in a certain time window. So for example, if you wanted to look for 5 failed login attempts followed by 1 successful login during a period of time, that's where a chain rule would be applicable. And then finally, aggregation rules. These are going to be triggered when up to 6 different events accumulate over time. For example, if you want to write a rule that looks for a large number of event types from a single device IP, you'd use an aggregation rule. Now, what I'm showing here is a blank rule template in Cloud SIEM, and you're going to have hands-on experience with this in a moment, but before you do, let's discuss it. What we have here is pretty simply 2 sides of the screen, left and right, if and then. So let's talk about the left-hand side of the screen. When a rule is created, we are going to configure the conditions it matches. And this is typically going to be a short piece of code and will depend on the rule type we're creating. We also have the ability to add rule tuning expressions, which are small exceptions to rules that are going to be appended with an end statement. Now, once we've set the conditions for the rule to fire, then we can create or configure the signal that will be created. This can include information like the name, the entity, the description, the MITRE attack tactic and techniques we're looking for with our rule. And then finally, we can configure the rule severity score. This is going to be on that scale from 0 to 10, 10 being the most severe. We might want to configure or set a severity of 0 if we want to monitor something, but not necessarily create insights for it. Higher severity scores are more likely to trigger insights. Now, before we create custom rules from scratch, there's going to be some best practices that we'd encourage you to follow. First, you want to check the existing rules in your system. As mentioned, Sumo Logic has hundreds of built-in rules, and so you may not need to write a new one. Or you may need to only make a small change to an existing rule, like adding a rule tuning expression or adjusting a severity score. Next, you want to know your system very well, and easier said than done, but it's important that you understand the schema and the log mappings of all the records that are ingested into Cloud SIEM so that you can write effective rules. And to do so, you might need to work with your administrator who has set up that side of things. So certainly you might want to collaborate with that individual. In addition to the system details about log mappings and other metadata, it's important that you understand your company's risk tolerance, their risk appetite, and their priorities. So here's an example. Some companies might want to monitor a large amount of outbound traffic, but not consider outbound traffic to be a threat. So they might assign the rule a severity of a 0. Another company might be alarmed by outbound traffic and consider it data exfiltration and assign the same rule a severity of 5. Both are correct. It's just what's more important to, or what priority for the organization. It's important that you understand all the types of the rules. So as I just described, those 4 different types, if your use case requires a chain rule, but you're trying to use a threshold rule, the rule might not be as efficient or as effective as it could be. As a best practice, when you make a new rule or edit an existing one, we encourage you to make small changes. So for example, if you want to decrease the severity score and you currently have that severity score at an 8, and you're thinking about bringing it down all the way to a 2, don't just go from 8 to 2, go to 8 to 7. See how things are going, monitor that change. Then go from 7 to 6 and start to bring it down. And then another best practice is going to be the ability or the functionality of saving all the rules, all the new rules as a prototype. And so by doing so, and we're going to do this in our lab examples, this allows us to monitor the rules behavior without creating new insights and alerts. All right, now talking about that rule tuning. Adding a rule tuning expression to an existing rule is one of the easiest and most common ways to customize your rules. And a rule tuning expression is going to be that end statement that we add to an existing rule. It's usually going to be simple logic we add to the rules. With the rule tuning, we can modify an existing rule without rewriting them from scratch. Once we've written a tuning expression, we can use that tuning expression across multiple rules. We can use multiple tuning expressions across a single rule, so we have a lot of flexibility. And we're going to learn how to apply one tuning expression to multiple rules, and then we're going to learn how to apply multiple tuning expressions to one rule in just a few moments. When you use rule tuning instead of custom rules, your tuning expressions are retained when Sumo updates that rule. And so you get the advantage of all the rules that Sumo pushes out to all its users. Now, once a rule is in the system, whether it's a custom rule that you created, one created by Sumo, regardless, Cloud SIEM is going to use it to create signals. Now, once again, this is getting a little repetitive, but that's okay, it should be. Once a record matches a rule, that entity is extracted from the record. That entity is that IP address, that username, the domain. Once the entity is in Cloud SIEM's system, the Cloud SIEM is then going to track this total severity score of signals associated with each entity as an activity score. And then once again, and we're going to look at this math in just a moment, once that activity score gets high enough, usually over 12, then an insight is going to be created. So let's start to look at this math and how it all adds up. And I think this should help kind of envision what's going on here. So what do we have going on here? What we have are, on the right-hand side of the screen, are signals from the last 14 days. We have 13 different signals in our system from the last 2 weeks. Each shape or color represents a different signal. So what do we have here? We have signals for entity A, which are represented by the pink triangles. We have entity B, which are represented by the green squares. And then we have entity C, which is represented by the blue circles. Based on the rule that fired, each of these signals has a severity score, which is that number that's in the object. Now remember, by default, an entity needs an activity score of 12 before an insight is created. And so what we have here are the pink triangles. We have the pink triangles, we have the blue circles, and we have the green squares. Now the question to you is, of those 3 signals, which are going to cluster into an insight? Think about it for a second. But now let's go ahead and look at the answer. Come on, there we go. So here's the answer. Entity A, those pink triangles, those are going to cluster together into an insight. Now there's only 3 of them, but they have relatively high severity scores. The total activity score is 7 plus 6 plus 5. And so those equal 18. And so those are clustered together into an insight. Entity B, which are the green squares, these are going to cluster to an insight as well. Now these scores are relatively low, 1s, 2s, 3, and 4, but there's a bunch of them. And so the total activity score for the entity B is 12, and so that turns into an insight. Now entity C, the blue circles, these will cluster into an insight, but the severity score is relatively low. And so what we have here, for C, they won't cluster into an insight because they're relatively low. These add up to be a 10. And so that's below the limit of 12. And so they don't turn into an insight. So what I wanted to show here, besides just the visualization, is the idea that you can have a large number of low severity score signals that don't create an insight. You might have a small number of high severity score signals that do create an insight. And so you want to keep this in mind when you're configuring those severity scores of your custom rules. All right, 1 or 2 more slides, and then we're back to the labs. Now, what if you want to be alerted right away when a certain rule is triggered and you don't want to wait for the default activity score of 12? Well, custom insights can help you. Custom insights lets you create insights based on one specific signal or a chain of signals, regardless of the severity scores. And this is going to be great for known threats that are specific to your system. And the other benefit of this is you don't need to change any of your existing rules and insights. They keep working normally. And so you won't have to adjust the default settings for activity scores. All right. So what I want to do now is jump back into the lab guide. So I have my lab guide, and what we're going to do now is jump into lab 4. So we're actually going to do lab 4, 5, and 6, and then we're going to essentially be done. So just kind of foreshadowing where we're going. So I have, that's not my lab guide. We'll keep losing my lab guide. Here it is. Over here. All right. And so now I have Sumo Logic still open. Hopefully have Sumo Logic, the Cloud SIEM Enterprise open. And ideally back to kind of the home page. And now let's grab the lab guide, and now let's do lab 4. And in lab 4, what we're going to do is we're going to create a rule tuning expression. So as it says, the example is pretty appropriate or good. Let's say we're updating some of the firewalls in our system and we don't want to trigger unnecessary alerts. What we're going to do is we're going to create a rule tuning expression that will allow us, and specifically us, to bypass firewall related rules. So how do we do that? Steps are in the guide. So we're going to go ahead and go to content, and we're going to go to rule tuning. When we go to rule tuning, we're going to see any rule tuning expressions that exist already. These are just other testers or people that have been playing in the system. And we're going to choose to create one. Now, when we create one, I'd like you to use the naming convention that we're encouraging you to use, which is going to be, for this example, it's going to be tuning expression JB234. So make sure you have those initials and those numbers. It makes it easier for me to identify later to clean things up. So if you could just use the naming convention we encourage you to use, that would be helpful. Now what we're going to do is we kind of fill in the blanks. So we have our rule tuning expression named, but now we need to actually have it do something. So what we're going to do is we're going to have it tune selected rules. Now, what rules do we want to have it tune? Well, as mentioned, we want to use the firewall rules. So we want to go ahead and look for a firewall, like I said, firewall rules. In this case, we're going to use the one this has the label of training on it. So now I'm tuning a selected rule, and here's my selected rule. Now what I need to do in this portion right here, and while it might not be obvious, this is a portion where you can add text in here. We want to add text. The text we want to add is in the PDF. I'm going to go ahead and copy and paste it. And I'm going to need to clean it up. One thing I may need to do here, and if you notice in the lab guide, the text is in red and here it's in gray. And this is an artifact of it being pasted from a PDF, is I'm just going to need to redo these apostrophes in there. And so now it turns into red. And so what I'm doing is I'm saying exclude essentially my user. Remember the not symbol. And now that I've created this rule tuning expression, I can go ahead and save it or submit it. If I did not fill it out properly, I might have a little triangle here with an orange triangle with a exclamation point, letting me know I did not fill out a field either properly or, but yeah, usually just properly. In this case, I did a good job, so I can click submit. It says created successfully. I can either believe that, or I can go back to content and rule tuning. And what I should see in here is my rule shortly. Should show up in there. Yeah, there it goes. There, and there are all the other ones. It was cached, I guess. And so now I see my rule, and whoever else is playing around with me. All right. So that's lab 5. Excuse me, that's lab 4 is creating the rule tuning expression. What we're going to do in lab 5 is now continue with this example. So in this example, we are, as it says in the lab, I'm kind of reading it, we're going to want to create a custom match rule. We're concerned about traffic coming from a particular IP address that's not covered by any of the default rules. And so what we want to do is create a match rule that looks for a specific IP. So what we're going to do is, follow the steps. We're going to go up to content, and we're going to go to rules. When we go to rules, we're going to see all those rules that have been created by Sumo Logic, as well as other rules that may have not been created by Sumo Logic. So here, primarily these top 4 have been created by other classes. But what we want to do is we want to go to content, we want to go to rules, and then we want to create a rule. Now, as mentioned earlier, knowing which type of rule you want to use is important. And here we're telling you, we want to use a match rule because we want to use kind of binary. It's either going to match this IP or it's not. So we're going to create. And now we're going to give it a name. So using that naming scheme and putting those numbers and initials. And as I'm filling this in, you'll see here on the bottom is that triangle that I was mentioning earlier, letting me know, hey, I need to fill this stuff in. And so let's fill it in. So we first want to fill in the portion of what do we want to have triggered. So what we want to have match is we want to have it match this IP address, which is the 127.0.0.1 address. Now, once again, when I paste this in, I may have to go ahead and redo the apostrophes to get them read. Now, what I'm going to do here is I'm going to add a tuning expression. And by doing so, I can go ahead and grab my current tuning expression that I just created to act as an end statement. So now it's going to be looking for this device IP and looking for that email address. And so we're starting to use these two together. Now on the right-hand side of the screen, if this is triggered where the IP address and the tuning expression, we want to now create the signal. Now, what do we want to create the signal on? What entity do we want to use? Well, device IP is probably going to be practical here because that's we want to use. Device IP is, it's pretty common to use. We can go ahead and put in our name and here, just to play along, signal JB234. The summary and description, I believe you can leave out. Those are not required. I'm going to put, yeah, those aren't required, but you can put test in there. And then what you can do is you can then select the score. So what severity do you want to have applied here? Is this a 0? Is it a 1? Is it a 10? Pick a value. Here we're just kind of playing along, so I'll just, I don't know, 7 seems good. Now I can also go ahead and utilize my tags here. And so I can have this apply the tactic of initial access from that MITRE ATT&CK framework. Now, before I save this, I'd like to encourage you to please click this rule, or by doing so, it will not generate insights, which is good in helping cleanse the training environment. And I should be able to click submit, but I'm missing something. Oh, a description. Okay, I did need that. So test, I can remember, I think. So now I should be able to submit it. And now I've created a rule using the rule tuning expression. I can once again go back to content and rules, and it should show up. It will show up. I'm being a little impatient, but. Where is it? It will show up eventually. I don't want to wait too long just to show you my rule. All right, let's see. Anything else in that lab? No, I think that's it for lab 5. Yep. So what we're going to do to finish things up is we're going to create a custom insight. And this is going to be lab 6. So to do so, we're going to go ahead and go to content and go to custom insights. And you'll notice when we go to content, and we're not really using many of these other options, there's a lot of different things here. We cover more of these in the admin class. So today we're using under content rules, rule tuning, and custom insights. But these other options are helpful. They're good. Just we only have so much time together. So let's go into content, go into custom insights. We see existing custom insights, so other people playing around, but now we can go ahead and create one. So to create one, click create, give it a name. Now for the if portion, we can go ahead and specify when signals are created from the following rule, we can select one of the rules. What we're going to do is we're going to select the rule that we created in step 5. So what we want to do is go to rules. And we should be able to find our rule. If you can't, you can pick somebody else's, it's not, we're just kind of messing around, but ideally you should have your own rule. So if it triggers your rule, we could specify order. Order is just not really relevant here. So we're just going to modify it to say any. And then under the create an insight, we can specify what gets created. So we're going to create an insight with this name. We're going to put a description. We're going to specify severity. We're going to specify our tags once again. And then we can click submit. And now we've created a custom insight. And once again, we should be able to go to custom insights, and I'm being impatient again. Ah, there it is. It showed up. All right. So that, let me just get back to the deck, but that concludes, that concludes the content for today from the slide presentation. So any questions? All right, so what we're going to do next, and if there's questions, as you guys have been doing, feel free to ask, but let's, kind of point you to the exam. So, feel a little repetitive here, but, let's wrap this up here. So once again, we're done with this class, and now we're going to take the exam. So just to show you where it is, because I should, It is, so if I'm in Sumo Logic, once again, we're going to go back into Sumo Logic, the SIP, Continuous Intelligence Platform, which is more the traditional environment of Sumo Logic. You're going to log in as yourself. We don't want to do this as a training user. We want to do this as you. And then we're going to go to certification and choose to get certified. Going to take a moment to load. Once it does, go in to get certified. And the exam we're going to be taking today is, where is it on here? Cloud SIEM Fundamentals exam. So this guy right here. As you see here, there is a Cloud SIEM administration. I certainly, if this was interesting to you, or maybe not interesting, but helpful, whatever, that admin class would be the next step. And that shows we go over the ingestion of the data, of records, and then parsing and things like that, which is pretty helpful. But for today, we're doing Cloud SIEM Fundamentals exam. Go ahead, click on it. And same ground rules as we've been doing. So this one is 20 questions. You have 60 minutes to take it. Once again, open book, open resource, open Google, open Matt. And so, use those references. They're there for you. They're there for you in the real world. And I think you should use them as much as you need them. So I'll go ahead and pause here before I, kind of kick it off to Matt and you guys taking the exam. Feel free to start, but, just see if there's any other questions. I think we're pretty good. I know you guys are probably drained. This is a lot of information, especially over 2 days. It's a lot of content. So for those of you that stuck with it, thank you. Hopefully if you learned something. All right. And so, yeah, I think we'll go ahead and kick you off to the exam. I'll leave Matt to proctor, but thank you again for attending. I've enjoyed you guys. You've been a lot of fun, good questions, good interaction. So appreciate that. Makes the time go by faster. So thank you. Good luck on the exam. And as a reminder, and Matt will remind you again, the most important thing, the Uber Eats. So as a reminder, I don't know, that's the most important, but do take advantage of this. You've now taken 3 exams, you're entitled to 3 meals. And so, please take advantage of those. Let's see, just a quick question here. If you don't pass the exam, which you're going to pass it anyhow, there is not a delay to either when you can take it or how many times you can take it. There may be some verbiage where you see you can only take it where it says you can only take it 1 time, but you can take it multiple times. So yeah, do it while it's fresh in your head, but life takes precedence. So it's there waiting for you. You will also, good question, Chris. You will have access to these labs after today. So the lab guide is, you have, and those credentials that I gave you, the ones that we've been using, are good for the rest of the month. So in fact, let me show you how to get the new ones. Yeah, let me show you how to get them. So those credentials, that security 22, feel free to use those credentials, like I said, through the rest of the month. Once again, they are training, so they may get deleted, but you're welcome to use them. But what I want you to point you to is, I think it's under here. If you go to become a Sumo Logic expert, yeah, okay, it is still here. Here are the current credentials. So next month when we change them on the first Monday of the month. The new password will be here. If you ever want to use our training admin accounts, you're welcome to. You just need to send us an email and we'll send you the password. No fee or anything, just those we manage just a little bit more closely. So, all right, so I'm going to be quiet because I feel like I've been talking a lot and I want you guys to take the exam. So thank you again. I'm going to put myself on mute. And oh yeah, let me show one other thing, one last thing, because Randy just asked about it. It's a good question. The question was how to get the slides we used today. So to do that, what we would do is we would go to recorded live training, and we would select the class we're interested in. And for today, of course, it's Cloud SIEM Fundamentals. We'll register for free. And what we have in here is the video will start to play. I'm going to pause it before it does. And then we have the slides in the lab guide. And I should have pointed this out to you yesterday, actually. Yeah, yesterday. But underneath here is pretty much all the classes. So what we do today, cloud security monitoring and analytics. If you weren't able to join, here's the video. If you were able to join but want the slides in the labs, here they are as well. So, whoop. And so all that content is available to you for free as well. So that's a good question to ask. So. All right, cool. So thank you all once again. I'm going to put myself on mute. I might come by and say hi just before I leave, but probably not. It's getting late. And so you're in good hands with Matt, James, and Stefan. You got a full house here. So best of luck, everybody. And thank you again.